Picture this. The first rays of dawn break over the horizon, casting long, dramatic shadows across the endless sands of Giza. Before you stand the pyramids, silent and majestic, their immense limestone blocks glowing with the warmth of the rising sun. It's a sight that has captivated humanity for thousands of years, but beyond their breathtaking beauty lies a puzzle so profound it continues to challenge everything we think we know about ancient engineering. How did a civilization without modern machinery, without steel tools, without even the wheel as we know it, achieve what seems almost impossible even by today's standards? This is the heart of the mystery. For centuries, archaeologists, engineers, and historians have tried to unravel the secrets behind ancient Egypt's most astonishing accomplishments. Yet despite all our advanced technology and deeper understanding, there are feats that simply defy explanation. We're talking about structures built with a precision that rivals modern laser-guided construction, alignment so exact they track celestial events with near-perfect accuracy, and innovations that appear to leap centuries ahead of their time. These aren't just ancient relics, they're masterpieces of engineering that continue to spark wonder, debate, and an insatiable curiosity about the brilliant minds behind them. So today, we're setting out on a journey together, a journey back through time to explore 30 of ancient Egypt's most baffling engineering achievements. From the blindingly clever mechanics hidden within the Great Pyramid to the mystifying methods used to transport and lift stone blocks weighing hundreds of tons, we'll venture into a world where ambition, creativity, and sheer human determination accomplished what many would call impossible. This is more than just a history lesson, it's an invitation to witness the extraordinary, and to marvel at the legacy of a civilization whose innovations continue to mystify and inspire us thousands of years later. And nowhere is this precision more breathtakingly displayed than in the very first feat on our list, the Great Pyramid's near-perfect alignment to the cardinal directions. We're not talking about a rough approximation here. The base of the Great Pyramid is aligned to true north with an error of just 3/60ths of a single degree. To put that almost incomprehensible accuracy into perspective, that's a margin of error of less than 1/15th of a degree. It is a level of precision that would be incredibly challenging to achieve today, even with our most advanced GPS systems, laser theodolites, and satellite technology. Yet, the builders of the Great Pyramid accomplished this over 4,500 years ago, working with nothing more than rudimentary tools and their own profound understanding of the heavens. So how did they do it? How does one orient a structure covering 13 acres of land with such minute accuracy using only the technology of the ancient world? This question has puzzled engineers and archaeologists for generations, and while no single theory has been universally accepted, several compelling methods have been proposed. One of the most enduring ideas involves the careful observation of the stars, specifically a pair of circumpolar stars known to the ancient Egyptians as Mizar and Khachab. These stars circle the celestial pole, and at a specific moment in time, one would be directly above the other, creating a perfect vertical line in the sky that could be used to ascertain true north. An observer would simply need to mark the position of these stars as they rotated and bisect the angle between their rising and setting points to find the celestial pole. It's an elegant method, but it requires incredibly patient and meticulous observation over many nights. Another plausible technique relies not on the stars, but on the sun. This method, known as the Indian Circle method, involves placing a central pole or gnomon and carefully marking the tip of its shadow at regular intervals throughout the day. By connecting these points, an arc is created. A line drawn through the center of this arc from the base of the pole would then run perfectly east to west. A line drawn perpendicular to that would then point directly north and south. While this sounds straightforward in theory, in practice it is a painstaking process highly susceptible to human error. The slightest miscalculation in marking a shadow's position, or a minor imperfection in the level of the ground, could throw the entire alignment off. The fact that the Egyptians executed this on such a monumental scale, with a margin of error so tiny, suggests an almost superhuman level of skill and patience. The true marvel lies in the application of this knowledge. It's one thing to understand these astronomical principles on a small, theoretical scale. It is something else entirely to translate that knowledge onto the Giza Plateau, to project a perfect celestial alignment down onto the rugged limestone bedrock, and then build the largest stone structure on Earth upon that line. The builders had to maintain this perfect orientation while quarrying and leveling the massive foundation stones, a task in itself that is another engineering mystery we will explore. This alignment wasn't just for show. It was deeply tied to their religious beliefs, connecting the pharaoh's mortal tomb to the eternal and unchanging cycles of the cosmos. The precision we struggle to explain today was, for them, a sacred necessity. But that same astonishing precision extends far beyond the pyramid's grand alignment and into the very stone from which it was built. Moving from the celestial to the geological, we encounter our second profound mystery: the Egyptians' seemingly impossible ability to cut and shape some of the hardest stones on Earth. Imagine trying to carve a sculpture out of solid granite using nothing but a copper chisel. You'd be lucky to leave a scratch. Granite, along with diorite and basalt, ranks among the most difficult materials to work, yet the ancient Egyptians fashioned these stones into immense statues, towering obelisks, and perfectly fitted sarcophagi with a flawless finish that feels almost glassy to the touch. The contradiction is staggering: a civilization in the Bronze Age, armed with tools made from a soft metal, mastering materials that would be a serious challenge even with our modern power tools. The evidence of their work is etched into the stone itself, quite literally. Archaeologists examining unfinished pieces and workshop debris have found clear, unmistakable saw marks in granite. These aren't rough gouges. They are long, straight, and parallel grooves that indicate the use of a sustained, mechanical cutting motion. Even more baffling are the drill holes. Cores extracted from deep within blocks of granite reveal the telltale spiral grooves of a tubular drill. The implications are extraordinary. This wasn't just bashing away with a hammer and chisel. This was a sophisticated process. The prevailing theory suggests they used copper saws and drill bits, but since copper is too soft to even mark granite, they must have employed a constant stream of an abrasive slurry. This abrasive, most likely common quartz sand, which is harder than granite, would have been fed into the cut. As the copper tool was moved back and forth or rotated, it would drag the sharp quartz particles beneath it, slowly grinding through the stone. But this is where the mystery deepens. Experiments using reconstructed copper saws and quartz sand can indeed cut granite, but the process is agonizingly slow, taking hours to make just a few millimeters of progress. The scale of Egyptian work, however, is monumental. The giant sarcophagus in the king's chamber of the Great Pyramid is made from a single block of granite so hard it emits a ringing sound when struck. Its interior and exterior surfaces are flawlessly smooth, and its corners are perfectly square. To achieve this with a slurry-fed copper saw would require an almost unimaginable amount of labor and time. Furthermore, the core samples show a consistent, deep drill hole with a feed rate, the speed at which the drill bit advanced into the stone, that is actually faster than what we can achieve with modern diamond-tipped drills using the same amount of pressure. How is that possible? This anomaly has led to intense debate and speculation. Some researchers propose they might have used a different, unknown type of drill, perhaps one with weighted handles for more consistent pressure, or even a mechanical apparatus for a more efficient motion. Others wonder if they had access to a lost abrasive material far more effective than quartz sand, though no evidence of such a substance has ever been found. The perfection of the surfaces pushes the mystery even further. How did they achieve such a mirror-like polish on these incredibly hard stones? The prevailing idea is that they used a process of relentless grinding with progressively finer abrasives, finishing with a paste of something like finely ground quartz or emery. But again, the sheer effort involved in polishing an entire granite sarcophagus to a glassy finish with handheld stones and sand is mind-boggling. It points to a level of dedication, skill, and perhaps even a technological secret that we have yet to fully comprehend. Their stonework stands as a silent testament to a mastery that seems to defy the limitations of their presumed toolkit, leaving us to wonder if we have underestimated their innovation or if there are chapters of their technological history that have been lost to time. Yet, the mastery of cutting and shaping stone leads to an even greater logistical puzzle. What happened after these colossal objects were created? How do you move a single block of stone, weighing as much as 500 tons from the quarries of Aswan to the temples of Luxor, or even farther north? This is the monumental challenge of the obelisk, one of ancient Egypt's most iconic and mystifying engineering achievements. These needle-like monuments, carved from a single piece of red granite, were symbols of the sun god Ra, reaching for the heavens. But before they could pierce the sky, they had to complete an incredible journey that, even with our modern understanding of physics and engineering, seems almost too audacious to be true. The process began in the granite quarries of Aswan, where the evidence of their work is still visible today. The most famous example is the unfinished obelisk, which remains partially attached to the bedrock, a haunting snapshot of a project that failed. This colossal stone, which would have been the largest obelisk ever erected at nearly 42 meters long and weighing an estimated 1,200 tons, cracked during its extraction and was abandoned. Yet its failure is our greatest success in understanding their methods. The obelisk's outline shows us that workers first carved trenches around the intended block, painstakingly chiseling away the granite with dolerite balls, a stone harder than granite itself. Then they would have tunnels underneath the monolith, inserting wooden beams. The theory is that by soaking the wood with water, the subsequent expansion would create enough pressure to slowly, incrementally, crack the obelisk free from the bedrock below. It was a high-stakes operation, and the crack in the unfinished obelisk is a stark reminder of how easily months or even years of labor could be lost in an instant. Once freed, the real challenge began: transportation. How do you move a 500-ton stone needle hundreds of kilometers along the Nile? The most widely accepted theory involves a three-part system of brute force, clever physics, and Egypt's greatest natural highway. First, the obelisk would have been loaded onto a massive, purpose-built sledge. We know the Egyptians used sledges for moving heavy statues, as depicted in tomb paintings. But for an obelisk, this sledge would have been an engineering marvel in itself, a colossal wooden frame of immense strength. To reduce friction, the path ahead would be turned into a makeshift road. The prevailing hypothesis, supported by a famous wall painting from the tomb of Djehuti, that shows a statue being moved on a sledge with a person pouring liquid in front of it, is that they wetted the sand. Water reduces the friction between the sledge runners and the sand by creating a thin, firm layer, essentially turning the path into a slippery mud that made pulling the incredible weight marginally easier. Experiments have shown this method can cut the pulling force required by half, but an obelisk is not a sturdy statue. It's a long, slender, and incredibly fragile object. The constant danger of it snapping under its own weight during transit must have been terrifying. The most likely solution was to transport it on a specially built, enormous barge during the Nile's annual flood. The river would have been the superhighway of the ancient world. The obelisk, securely lashed to its sledge, would be dragged to the riverbank and then, in a feat of incredible coordination, rolled or levered onto a waiting barge. Historians like Herodotus described specially constructed boats made from acacia wood, held together with massive ropes, capable of carrying these unparalleled loads. The current of the Nile would have done most of the work carrying the barge north, but maneuvering it in and out of canals and avoiding sandbanks with such a top-heavy, precious cargo would have required immense skill from the crews. Finally, after this epic journey, came the most dramatic and dangerous phase: erection. How do you lift a 500-ton stone pillar from a horizontal position on the ground and stand it upright perfectly vertical, without it crashing to the ground? This remains one of the most debated aspects of the entire process. The most plausible theory involves the construction of a massive earthen ramp next to the obelisk's intended foundation. The obelisk on its sledge would be pulled up this ramp at a shallow angle. At the top, a vertical, open-sided pit would have been prepared, filled with sand. The base of the obelisk would be carefully maneuvered over this pit. Then, the sand would be slowly and systematically removed from the pit through side tunnels. As the sand drained away, the obelisk would gradually, grain by grain, settle downward, pivoting on its base until it stood upright in the pit. It was a slow-motion ballet of engineering, requiring perfect timing and coordination to ensure the obelisk didn't slip or topple. The ramp would then be dismantled, leaving the obelisk standing alone, a testament to a logistics operation that rivals any mega project of the modern era. The lack of definitive archaeological evidence for these ramps only deepens the mystery, forcing us to admire the result while the precise methods remain a subject of awe and speculation. And this obsession with moving and erecting monolithic stone extends from the sun-drenched temples above ground to the shadowy, silent world beneath the sand. If the obelisks represent a triumph of logistics, then the contents of the Serapeum of Saqqara represent a mystery of almost supernatural precision. Deep below the desert, a labyrinth of massive tunnels and niches was carved from the living rock. And within these chambers rest 24 gargantuan sarcophagi, each one carved from a single, solid block of either granite or diorite, some of the hardest stones on the planet. The sheer weight of these boxes is staggering, with each one estimated to weigh between 70 and 100 tons. But the weight is not the most baffling part. It's the impossible craftsmanship that went into their creation. The precision on display here is, in a word, inhuman. The surfaces of these coffins, both inside and out, are polished to an absolutely flawless, mirror-like finish that feels like glass under your fingertips. The corners are perfectly square, and the surfaces are utterly flat. The most often cited detail, and one that has been verified by modern explorers, is the fit of the lids. These multi-ton slabs of granite were carved to sit on the main box with such perfection that not even a single piece of paper, or in some cases a human hair, can be slid into the seam. This level of exactitude implies a manufacturing process far beyond simple chiseling and hammering. It speaks to a method of shaping and finishing stone that we would today call precision engineering. It's the kind of work you would expect from a modern machine shop using computer-guided milling equipment, not from artisans working in dimly lit underground chambers over 2,000 years ago. This leads to the obvious and profound question: how was this achieved? The tools officially attributed to the ancient Egyptians, copper chisels, dolerite balls, and sand abrasives, seem woefully inadequate for the task. While the abrasive theory explains how they could eventually grind down the stone, it fails to fully explain how they achieved such perfect geometry and such a sublime finish on the interior surfaces. The inside corners of these boxes are sharp and precise, a feat incredibly difficult to accomplish with handheld tools. Some researchers and engineers who have examined the sarcophagi point to the presence of what appear to be tool marks that suggest the use of a fixed, mechanical cutting tool, perhaps a type of saw or drill that could move in a perfectly straight line with immense force and consistency. The idea that the Egyptians might have possessed some form of advanced, lost machining technology is a controversial but persistent theory, born from the simple fact that the finished product so thoroughly defies conventional explanation. Then there is the puzzle of placement. These aren't sitting in an open quarry or a wide workshop. They are housed in narrow, underground tunnels, often placed into niches that are only slightly larger than the sarcophagi themselves. How did the builders maneuver these 100-ton monoliths through tight, winding subterranean passageways, and then lower them with pinpoint accuracy into their designated spots? The tunnels are simply too confined to have allowed for the construction of large earthen ramps or the use of big teams of laborers pulling on ropes. The most plausible theory suggests an ingenious use of counterweights and leverage. Workers may have built sturdy wooden frameworks around the sarcophagus and then used a system of levers, ropes, and sandbags to ever so slowly and carefully walk the giant box into its final position, centimeter by painstaking centimeter. It would have been a terrifyingly delicate operation conducted in cramped, dark quarters, where a single slip could have meant disaster. Finally, we are left to ponder the purpose. The conventional explanation is that the Serapeum was the burial place for the sacred Epes bulls, creatures worshipped as incarnations of the god Ptah. While later Ptolemaic chambers do contain bull remains, the earlier, precision-made boxes from the New Kingdom era are empty. No bull bones, no grave goods, nothing. This glaring absence has fueled alternative theories. Could these perfect, enigmatic boxes have served another, more mysterious purpose? Were they intended to hold something else entirely, or perhaps designed to function as resonant chambers for some unknown ritual or energy? The combination of their staggering precision, their hidden underground location, and their unexplained emptiness creates a mystery that is as deep and impenetrable as the stone from which they were made. They stand as a silent, polished enigma, challenging our understanding of ancient technology and hinting at secrets that remain buried just beyond our reach. Now, let's move from the tangible mysteries of massive stone and into the realm of speculation, where artistry and symbolism collide with a tantalizing what-if. High up on a wall in the ancient Hathor temple at Dendera is a series of reliefs that have sparked one of the most controversial and imaginative theories in all of Egyptology. The images are striking and undeniably unusual. They show what appears to be a large, elongated glass bulb, curled at one end like a giant tulip. Inside this bulb is a snake, stretching its body along the length of the object. A wire or cable seems to connect from the bulb to a box, upon which a kneeling figure rests their hands. Another figure stands nearby, holding what look like sharp instruments. To a modern eye, the resemblance to a Crookes tube or an early light bulb is almost irresistible. This has led some to propose a radical idea, that the ancient Egyptians possessed, and were depicting, a form of electrical technology. The alternative theory, often called the Dendera light bulb hypothesis, is compelling in its simplicity. Proponents point to the absence of soot in some deep, interior temple chambers and tombs, asking how such intricate artwork could have been completed in total darkness. They suggest that these reliefs are literal blueprints for a lighting device. The snake represents the glowing filament, the bulb is the glass enclosure, the cable is an electrical wire, and the box is a power source, perhaps a battery of some kind. This idea is often supported by a fascinating archaeological find from nearby Mesopotamia, the so-called Baghdad Battery. This artifact, dating from the Parthian period centuries later, consists of a clay jar, a copper cylinder, and an iron rod. When filled with an acidic liquid like vinegar, it can produce a small electrical charge. Could the Egyptians have developed a similar, more advanced technology? However, the mainstream Egyptological interpretation of these reliefs is vastly different, and it is rooted not in electrical engineering, but in deeply complex Egyptian mythology. Egyptologists identify the central object not as a bulb, but as a lotus flower, a symbol of creation and rebirth. The snake emerging from it is interpreted as the serpent god Hemsut, representing the primordial life force and the moment of creation itself. The entire scene is a well-documented depiction of a cosmic concept. The lotus flower, which closes and sinks underwater at night and reblooms at dawn, was a powerful symbol of the sun's daily rebirth. The snake bursting forth from it is a visual metaphor for the sun god emerging from the lotus to bring light to the world. The cable is likely a ceremonial rope or a stylized stem, and the instruments held by the figures are more probably ritual knives used in symbolic ceremonies. The box is thought to be a jed pillar, a symbol of stability, or a chest holding sacred items. The biggest challenge for the light bulb theory is a complete lack of physical evidence. Despite extensive excavations across Egypt, not a single component of an electrical system, no wires, no bulbs, no batteries, no generators, has ever been discovered. The Baghdad Battery remains an isolated, enigmatic object whose true purpose is still debated by historians. It may have been used for electroplating jewelry or even held a sacred scroll. Furthermore, the soot-free chamber's argument is easily countered by the ingenious use of mirrors to reflect sunlight deep into temple corridors, a practice we know the Egyptians mastered. While the imagery at Dendera is certainly unusual and captures our modern imagination, it fits perfectly within the known and richly documented symbolic language of ancient Egyptian religious art. What we see as a technical schematic was, for them, a profound spiritual statement about the nature of life, light, and the universe. This fascinating controversy serves as a powerful reminder of how our own modern perspective can shape the way we interpret the past, sometimes seeing advanced technology where ancient people saw divine mystery. This staggering precision hidden deep within the Great Pyramid presents a contrast that is as confusing as it is brilliant. While the outer casing stones, now almost entirely gone, were famously smooth and perfectly angled, the inner core masonry was long assumed to be a rougher, purely functional fill. But that assumption shatters upon closer inspection. The massive limestone blocks that form the pyramid's heart, some weighing several tons each, are fitted together with a joinery so exact it defies belief. The gaps between these stones are often less than 1/50th of an inch, a width thinner than a credit card, and a tolerance that rivals the precision of modern machine shops. You cannot slide a razor blade between them. This isn't just good masonry. It is a level of perfection that seems to belong to another era entirely, a signature of technology that simply should not exist in the 26th century before the Common Era. The mystery only deepens when we consider the tools the Egyptians are known to have used. Copper chisels, wooden mallets, and dolerite pounding stones are effective on relatively soft limestone, but they are blunt instruments. Achieving a fit this precise with such tools would be like trying to carve a perfect sphere with a sledgehammer. It's not just about brute force, it's about measurement, control, and a method for creating a perfectly flat plane across an entire multi-ton block. The conventional explanation involves the use of a simple yet effective tool called a boning rod. This is a straight edge used in tandem with a plumb bob to check for flatness. Masons would have painstakingly shaved down high spots on the stone by hand, constantly checking with the boning rod, a process of incremental refinement that is almost unimaginably slow and labor-intensive for the sheer volume of stone in the pyramid's core. This has led to a fascinating and controversial theory, that the ancient Egyptians might have possessed a lost method for chemically softening stone. The idea proposes that they could have applied a naturally occurring mineral acid or a plant-based solution to the surface of the limestone. This would have turned the hard stone into a malleable paste, allowing workers to shape it easily, almost like clay, before it rehardened into its final, glassy smooth form. Proponents of this theory point to certain stone vessels from pre-dynastic Egypt that have complex, seemingly lathe-turned shapes and internal handles that are notoriously difficult to carve with primitive tools. They argue a form of mineral alchemy could explain these artifacts and the pyramid's perfect joints. However, this remains firmly in the realm of speculation. No residue of such a softening agent has ever been conclusively identified on the stones, and no recipe for such a substance has been found in any hieroglyphic text. The alternative, and perhaps even more mind-bending, suggestion is that the builders used a form of advanced, unknown cutting technology. Some engineers who have studied the joints point out that the perfection is so consistent across thousands of blocks that it hints at a process more repeatable and precise than hand-fitting. They speculate about the possibility of large, guided saws, perhaps using water or sand as an abrasive, that could make long, perfectly straight cuts. Others have even noted that the stone itself sometimes has a slightly vitrified, or melted, look to its surface, wondering if some form of directed heat was involved. While there is no archaeological evidence for such machines, the finished product continues to fuel the debate, standing as a silent challenge to our historical timeline. What makes this inner precision even more intriguing is the stark contrast with the pyramid's original exterior. The famous white Tura limestone casing stones were cut with equal precision on their outer, visible face and their bottom surface that locked onto the layer below. However, the sides and backs of these casing blocks were often left rough and unfinished. This reveals a profound insight into the builder's priorities and methods. They were masters of efficiency. They invested their incredible skill and painstaking effort only where it was absolutely necessary on the critical mating surfaces that ensured structural integrity, and on the beautiful exterior that the world would see. The hidden core blocks, never meant to be visible, received the same meticulous attention on their mating surfaces purely for stability, proving that their precision was not merely artistic, it was fundamentally structural. This was an engineering mindset of the highest order, achieving monumental goals with a brilliant economy of effort, yet leaving behind a signature of skill that we are still struggling to fully decipher thousands of years later. But if the pyramids represent the pinnacle of stonework, then the discovery at their feet reveals an equally astonishing mastery of wood. In 1954, just south of the Great Pyramid, archaeologists made a find that was both breathtakingly unexpected and miraculously preserved. They uncovered a series of limestone blocks sealing a rectangular pit carved directly from the Giza bedrock. When carefully opened, the pit revealed not treasure in the conventional sense, but a time capsule of ancient engineering, an intact, full-sized wooden ship, disassembled into 1,224 individual pieces and laid in a meticulously organized stack. This was the solar boat, a vessel dating back over 4,500 years, buried as part of the funerary equipment for the pharaoh Khufu himself. The task of reconstructing this ancient puzzle fell to a team of dedicated experts, a process that itself became a marvel of modern archaeology. It took years of painstaking work, as each piece had to be carefully documented, conserved, and understood before it could be placed. There were no instructions, no blueprints to follow, just the logical shapes of the timbers and the ghost of the original shipwright's intent. When finally completed, the result was staggering. A majestic vessel measuring 143 feet from prow to stern. This was not a symbolic model or a simple river barge. This was a fully functional, seafaring ship, a testament to a naval architecture that was centuries ahead of its time. The construction methods are what truly baffle engineers and historians. This colossal boat was built without a single metal nail. Instead, the ancient shipwrights used an intricate system of mortise and tenon joints, carefully carved and fitted together, and then secured with ropes. This technique, known as lash lug construction, used the natural flexibility of the wood and the strength of the rope bindings to create a hull that was both incredibly strong and surprisingly flexible. A rigid, nailed ship would be brittle and could crack under the stress of waves, but this lashed design allowed the solar boat to move and flex with the water, a principle still used in boat building today. The precision of the cuts, the complexity of the joinery, and the understanding of hydrodynamics all point to a level of sophistication that we scarcely attribute to the earliest dynasties. They used primarily Lebanese cedar wood, a material chosen for its durability, resistance to rot, and aromatic quality, which was painstakingly imported from hundreds of miles away. The purpose of this incredible vessel is a subject of rich debate, weaving together practical function and deep spiritual belief. The most accepted theory is that it was a solar barge, a ritual vessel intended to carry the resurrected pharaoh alongside the sun god Ra across the heavens in the afterlife. This symbolic journey mirrored the sun's daily passage, a fundamental concept in Egyptian cosmology. However, the boat's clear seaworthiness suggests a possible secondary purpose. Some scholars argue it may have been a functional, funerary barge, used to transport Khufu's mummy on his final journey across the Nile to the Giza necropolis. There's even a more intriguing possibility, that it was actually used by the pharaoh during his lifetime, a real ship later ritually buried for his eternal use. The truth likely combines all these ideas. It was a masterpiece of practical engineering imbued with profound religious significance. Perhaps the most pressing question, however, is how it survived. How did a wooden structure, over 45 centuries old, endure in such a remarkable state of preservation? The answer lies in the ancient Egyptians' ingenious, passive preservation system. The boat was sealed in its limestone pit, which was almost perfectly airtight. This created a microenvironment, shielding the wood from the two great enemies of organic material, oxygen and insects. Without oxygen, destructive aerobic bacteria could not thrive. Without any air exchange, wood-boring insects could not infiltrate. The dry, stable climate of the sealed chamber prevented the cycles of expansion, contraction, and moisture that normally cause wood to rot and disintegrate over time. It was a perfect, natural time capsule, a testament to their understanding of their environment, even if that understanding was intuitive rather than scientific. The solar boat is more than just a relic. It is a direct message from the age of the pyramid builders, showcasing a nautical engineering prowess that was as advanced as their architectural genius and a spiritual vision that reached for the stars. Yet for all the incredible structures that have survived, one of the greatest engineering feats of ancient Egypt is known more for its absence than its presence, a legendary complex, so vast it was said to dwarf even the pyramids. The Greek historian Herodotus, who walked its halls in the 5th century before the Common Era, described it with a sense of awe that has echoed down the millennia. He wrote of a colossal labyrinth located near the Pyramid of Amenemhat III at Hawara, a structure containing 3,000 rooms, 1,500 underground and 1,500 above hill, connected by a bewildering maze of courtyards, corridors, and chambers. He claimed its roof was made entirely of stone. Its walls were covered with intricate carvings, and it was so complex that without a guide, one would never find their way out. To Herodotus, the pyramids were magnificent, but the labyrinth was beyond compare. For centuries, his account was dismissed as an exaggeration, a traveler's tall tale. How could such an immense building simply vanish without a trace? The mystery only deepened over time, as the site at Hawara appeared to be little more than a vast, featureless field of rubble next to the pharaoh's eroded pyramid. The turning point came in the late 19th century, and then again with modern archaeological surveys. Excavators like Flinders Petrie discovered that beneath the sand lay a single, gigantic foundation slab of limestone, covering an area of over 65,000 square feet. This wasn't the foundation for a small temple or a palace. This was the footprint of something monumental. Ground-penetrating radar and other geophysical techniques have since revealed a grid-like structure underneath the earth, a ghostly outline of walls and chambers that precisely matches Herodotus's description of an underground complex. The legend, it seems, was real. This confirmation only leads to more profound questions. What was the purpose of such an incomprehensibly large building? The scale suggests it was far more than just a tomb complex for the pharaoh, though that was likely part of its function. One compelling theory is that it served as a central administrative capital for the entire region of Fayum, a buzzing hive of bureaucracy where priests, officials, and scribes managed the kingdom's vast agricultural wealth and resources. Another, more spiritual idea posits that it was a grand temple complex dedicated to the countless local deities and crocodile gods of the Fayum, a place of pilgrimage where every nome, or province, had its own sacred chamber. This would align with descriptions of its walls being covered with countless religious scenes. Perhaps it was even a memorial to the king himself, a stone representation of his eternal power and the complexity of his ruled world. The greatest mystery of the Hawara labyrinth may not be why it was built, but why it was so completely dismantled. Unlike the pyramids, which were stripped of their smooth casing stones, but whose cores remain, the labyrinth was systematically quarried away. For centuries, its perfectly cut limestone blocks were a convenient source of building material for later Roman, Coptic, and Islamic settlements in the area. Its disappearance was not an act of nature, but a calculated recycling project that erased one of the ancient world's wonders. We are left with a colossal foundation and the tantalizing words of an ancient historian, forcing us to imagine the sheer ambition of a society that could conceive of and construct a building so vast its very existence flirted with the edge of myth. Moving from the mythical scale of the lost labyrinth to the brilliantly practical, we find one of history's most overlooked marvels not in a grand temple, but deep within the foundations of a pyramid. The complex of Pharaoh Sahur at Abusir, built around 2400 BCE, is a masterpiece of funerary architecture. But its most astonishing feature is one that visitors would never see: an incredibly advanced, complex plumbing system that reveals the Egyptians were not just masters of stone, but pioneers of hydraulic engineering. This isn't a simple drain hole. It's a carefully designed network of copper pipes and limestone channels that shows a sophisticated understanding of water pressure, flow, and prevention of erosion that feels centuries ahead of its time. The entire Sahir complex was designed as a miniature, eternal world for the pharaoh, complete with a valley temple, a causeway, and the main pyramid. All of these structures had vast, sloped limestone roofs designed to collect rainwater. And where there is collected water, there is the potential for catastrophic flooding and structural damage. The Egyptian engineers solved this problem with breathtaking foresight. They embedded a system of drainage channels directly into the masonry of the walls. These weren't just ditches, they were carefully cut grooves with specific slopes, designed to control the speed and direction of the water. The channels then fed into something even more remarkable: pipes made of heavy, beaten copper. Sections of these pipes have been found, demonstrating they were crafted to fit together, creating sealed conduits that would carry the water away from the sacred architecture and safely discharge it onto the desert sand. The ingenuity lies in the details of their design. The copper pipes were not straight, they were often bent at precise angles. This shows an understanding that sharp, 90-degree angles would cause turbulence and backflow, potentially leading to blockages or overflows. Instead, they used gentler curves to maintain a smooth, consistent flow of water, minimizing the chance of a clog. Furthermore, the entire system was designed with a calculated gradient. The channels and pipes were laid with a constant, slight decline, ensuring that gravity would pull the water efficiently through the system without it ever pooling or stagnating inside the walls, which would have led to slow, destructive leaks over centuries. This is applied physics of a very high order, solving problems that would challenge any modern plumber. Why was this so necessary? The answer lies in the very nature of their building material. While the desert is dry, the rare downpours can be torrential. When water penetrates limestone, it doesn't just cause surface damage. It seeps into the porous rock, and then, under the heat of the sun, the water trapped inside expands as it turns to vapor. This creates immense internal pressure, literally exploding the stone from the inside out in a process called spalling. The entire structural integrity of their meticulously carved reliefs and monuments was at stake. The Sahir drainage system was a brilliant preemptive strike against this inevitable decay, a method of preserving the pharaoh's eternal home not through magic, but through fundamental engineering. This revelation makes its absence elsewhere so puzzling. If they had this knowledge in the 5th dynasty, why isn't such advanced plumbing a standard feature in every major pyramid complex that followed? The answer might lie in a combination of economics and changing priorities. Copper was an incredibly valuable and expensive commodity in ancient Egypt, often compared to the value of modern gold. Sahir, who launched major expeditions to mine copper and turquoise in the Sinai, may have had the unique resources to implement such a lavish and metal-intensive solution. Later pharaohs, facing different economic pressures or perhaps different architectural styles with less massive, water-catching roofs, may have opted for simpler, cheaper drainage solutions using only stone gutters, which have since eroded away to invisibility. The system at Sahir stands as a brilliant, but perhaps prohibitively costly, flash of genius, a glimpse of an advanced technological pathway that, for reasons lost to history, was not fully pursued. It proves that their engineering imagination was boundless, even if their resources were not. Yet, for all their staggering successes, the ancient Egyptian engineers were not infallible gods of stone, but human innovators who learned through trial and error. And perhaps no single structure better illustrates a costly, monumental error than the haunting ruin known as the Black Pyramid of Dashur. Built for Pharaoh Amenemhat III, this pyramid began with the same soaring ambition as its predecessors at Giza. But where those structures have stood for millennia, the Black Pyramid suffered a catastrophic structural collapse, likely within just a few decades of its completion. It stands today not as a sharp-edged monument to eternity, but as a crumbling, unstable mound, its original form barely recognizable. Its failure is a fascinating counterpoint to the enduring pyramids, a forensic engineering puzzle that reveals the limits of their knowledge and the critical importance of fundamentals they had seemingly mastered elsewhere. The root of the disaster lies in its very foundation, both literally and figuratively. While the builders of the Great Pyramid at Giza took immense pains to level the bedrock and create a perfectly stable base, the builders at Dashur chose a site on soft, unstable clay soil near the Nile floodplain. This was the first and perhaps most critical mistake. A pyramid is the heaviest structure imaginable, exerting immense, concentrated pressure downward. Placing such a load on compressible soil is a recipe for disaster. Almost immediately after construction began, the weight of the rising masonry began to cause differential settlement. This means some parts of the foundation sank faster and deeper than others, creating uneven stresses that began to tear the structure apart from the bottom up. You can see the evidence of this today in the deep cracks that radiate through the pyramid's core like shattered glass. Compounding this foundational flaw was a fateful decision in its construction material. Unlike the pyramids at Giza, which were built almost entirely from massive blocks of solid limestone, the Black Pyramid employed a radically different and fatally flawed technique. Its inner core was not made of stone, but of sun-dried mud bricks. These bricks, made from Nile silt and straw, were cheap, easy to produce, and quick to stack. On the surface, it must have seemed like an efficient shortcut, but mud brick is fundamentally weak and highly susceptible to water infiltration. The entire structure was then encased in a beautiful, gleaming white Tura limestone shell, intended to give it the appearance of a solid stone pyramid. This created a deadly mismatch, a hard, rigid, brittle outer skin trying to contain a soft, shifting, and unstable inner core. As the muddy foundation settled unevenly, the stone casing, unable to flex, simply cracked under the strain. Once those cracks appeared, the desert rains seeped in, steadily dissolving the mud brick heart from within. The pyramid was quite literally melting from the inside out. This leads to the profound question, why would a civilization with such a proven track record of engineering perfection, a culture that had successfully built dozens of pyramids before, make such elementary mistakes? The answer is likely a complex mix of shifting priorities, economic pressures, and perhaps even a touch of hubris. Amenemhat III's reign was long and prosperous, but his ambitions were vast. He was also building his famous labyrinth at Hawara and financing massive irrigation projects in the Fayum. The mud brick core may have been a cost-cutting measure, a way to achieve the desired monumental scale, without the crippling expense and time of quarrying and moving millions of tons of solid stone. There may also have been a belief that their engineering skill could overcome the material's weakness, that the strong limestone casing would be enough to hold it all together. They learned the hard way that it was not. The collapse of the Black Pyramid was not an invisible failure. It was a very public and undoubtedly embarrassing disaster for the priesthood and the royal court. But it was also a powerful lesson that resonated through Egyptian history. Later pyramid builders clearly studied this failure. Pharaohs of the subsequent 13th dynasty, who built their pyramids at Dashur and Saqqara, visibly adapted their techniques in direct response. Their pyramids are much smaller and far more conservative in scale, acknowledging a newfound respect for structural limits. More importantly, they returned to using solid stone cores or employed much more sophisticated internal frameworks of stone walls and crossbeams to stabilize the rubble and mud brick fill, creating a much more cohesive and resilient structure. The failure of the Black Pyramid taught them that a pyramid's strength had to come from within, from a unified and stable core, not just a pretty facade. In this way, the crumbling ruin at Dashur is as much a testament to the Egyptian capacity for learning and adaptation as the perfect pyramids of Giza are to their initial genius. It shows us that their engineering knowledge was not a static set of rules, but a living, evolving science, forged as much in the agony of failure as in the triumph of success. Leaving the silent, inland mysteries of pyramids and tombs, we journey to the banks of the Nile, where two seated giants have kept their vigil for over 3,400 years. These are the Colossi of Memnon, twin statues of Pharaoh Amenhotep III, each carved from a single, unbelievable block of quartzite sandstone weighing an estimated 720 tons. To stand before them is to feel a profound sense of awe. Not just at their sheer scale, they tower over 60 feet high, but at the incredible logistical operation that brought them here. But their greatest fame comes from a brief, mysterious period in their long history, when one of these silent stone gods was said to sing at the break of dawn, a haunting melody that turned a damaged monument into one of the ancient world's most celebrated oracles. The story of their journey begins in the quarries near modern-day Cairo, over 420 miles down the Nile from their final resting place at Amenhotep's mortuary temple in Thebes. Moving a single 700-ton block is a challenge we've touched on with obelisks, but these statues presented a unique problem. They were not sleek pillars, but bulky, irregular seated figures with projecting arms and legs, making them infinitely more difficult to balance and transport. The method was likely a combination of everything the Egyptians had mastered. They would have been loaded onto a gargantuan, reinforced barge during the Nile's annual inundation, when the floodwaters dramatically raised the river level, making it possible to float such an immense load. The journey north would have been a slow, careful procession against the current, a task requiring immense skill from the crews to avoid capsizing the top-heavy, precious cargo. Upon arrival, the same system of sledges, lubricated pathways, and sheer human power would have been used to drag them into position, a feat of coordination that must have been breathtaking to witness. For centuries, the two colossi sat in silence, guarding the entrance to a temple complex that was itself one of the largest ever built, though it has since largely vanished, its stones recycled by later builders. Then, in the year 27 before the Common Era, a massive earthquake struck the Theban region. It caused significant damage to the northern colossus, cracking its massive torso and shearing off the top half. It was this act of destruction that inadvertently gave birth to its legend. Shortly after the earthquake, visitors began reporting that the damaged statue would emit a strange, melodic sound, a low hum or a faint whistling song, always just as the first rays of the sun warmed its stone surface. The sound was interpreted as the voice of the hero Memnon, son of the dawn goddess Eos, greeting his mother each morning. This beautiful story spread throughout the Greco-Roman world, and the Colossus became a mandatory stop on the grand tour of the ancient world. Emperors, poets, and pilgrims flocked to hear the miraculous sound, inscribing their experiences on the statue's legs, with many claiming it brought them good fortune. So what was the source of this mysterious dawn chorus? The most compelling scientific explanation is a fascinating interplay of natural physics and accidental engineering. Quartzite is an extremely dense, hard stone, and the earthquake had created a network of internal fissures and cracks within the statue's lower half. The desert night air is cool and humid. As the first light of the sun struck the cold stone at dawn, it would cause a rapid thermal expansion. The stone would heat up quickly, and this sudden temperature change would evaporate the moisture trapped within the labyrinth of cracks. This newly heated air, now under pressure and desperate to escape, would be forced through the narrow fissures, creating a vibrating, resonant sound, much like the sound you get from blowing across the top of a glass bottle. The phenomenon is known as acoustic resonance, and the specific time and weather conditions explain why the song was only heard at a precise moment at dawn under the right humidity conditions. The legend of the singing Colossus, however, came to an abrupt end. In the 3rd century of the Common Era, the Roman Emperor Septimius Severus, a devout believer in the oracle, visited hoping to hear the song. When he was met with silence, perhaps due to a particularly dry season, he took it upon himself to repair the damaged statue out of reverence, ordering the cracked upper torso to be reassembled using the same quartzite blocks. This well-intentioned act of preservation was, in fact, the very thing that silenced Memnon forever. By filling in the cracks and sealing the internal chambers, he unknowingly removed the very mechanism that created the sound. The moisture could no longer be trapped and heated, the air could no longer escape through narrow passages, and the resonance was lost. The Colossus returned to being a magnificent, but silent, guardian. This episode is a profound lesson in unintended consequences. It shows that the ancient world's most wondrous phenomena were often not magic, but a spectacular, accidental convergence of natural law and human creation. The Egyptians may not have engineered the statue to sing, but their mastery in selecting such a specific stone and their ability to move it into place created the perfect conditions for nature to perform a miracle of its own, a fleeting harmony of stone, sun, and sound that captivated the world for centuries. Yet the ambition to carve ever larger monoliths inevitably pushed against the very limits of stone itself, a lesson permanently etched into the red granite bedrock of the Aswan quarries. Here lies the unfinished obelisk, a breathtaking testament to both staggering ambition and catastrophic failure. Had it been completed, it would have dwarfed every other obelisk ever created, soaring to a height of nearly 42 meters and weighing an estimated 1,200 tons. But it was never freed. Deep, cruel fissures appeared in the stone during its extraction, forcing the ancient workers to abandon a project that had already consumed an unimaginable amount of labor and time. This colossal fragment is not a ruin. It is a frozen moment, an archaeological snapshot that reveals the secrets of ancient Egyptian stoneworking with a clarity no finished monument ever could. The first lesson it teaches is the sheer, brutal physicality of their quarrying process. The entire outline of the obelisk is visible, showing us they didn't carve it out from the top down. Instead, they began by carving deep, narrow trenches barely wide enough for a person to work in all the way around the intended monolith. And they did this with the simplest of tools, handheld pounders made of dolerite, a stone even harder than the granite itself. Teams of workers would have stood in these trenches, relentlessly swinging these heavy stone balls, pulverizing the granite into a coarse sand grain by grain. The trenches surrounding the unfinished obelisk are still littered with these dolerite pounders, left behind as if the workers had just stepped away for a break. The amount of labor this represents is almost incomprehensible. It was a battle of attrition against the stone, one not with clever machinery, but with relentless human effort and time. But the real engineering genius, and the highest risk, came next, the process of undercutting. Once the trenches were deep enough, workers would have had to tunnel beneath the 7-story-tall stone block to separate it from the bedrock below. This is where the mystery of their technique truly lies. The most plausible theory involves a clever exploitation of wood's natural properties. They likely carved a series of tunnels and channels underneath the obelisk and inserted freshly cut wooden beams. These beams would then be thoroughly soaked with water. As the wood absorbed the water, it would expand, and within the confined space of the tunnels, this expansion would generate immense, irresistible pressure. This pressure would, theoretically, create a clean shear plane, cleanly cracking the obelisk free from its base. It was an incredibly dangerous gambit, a high-stakes operation where controlling the immense forces of nature was paramount. In the case of the unfinished obelisk, it's believed this process either failed to create a clean break, causing the stone to crack in the wrong place, or that the latent fissures in the stone itself gave way under the tremendous strain. This leads to the profound question of why. Why would the pharaoh's engineers even attempt a project of such insane scale and risk? The answer lies in the very purpose of these monuments. Obelisks were not merely decorative, they were conduits to the divine, symbols of the first ray of sunlight that pierced the primordial darkness, according to Egyptian mythology. They were the petrified fingertips of the gods. A larger obelisk meant a stronger connection, a greater offering, and a more powerful declaration of a pharaoh's eternal legacy. The attempt to build the largest obelisk in history was likely driven by a pharaoh's desire for ultimate immortality, a boast in stone that would forever cement their name above all others. The unfinished obelisk is a powerful reminder that Egyptian engineering was not a cold, calculated science, but was often fueled by a potent mix of religious fervor and royal ego, pushing their technological capabilities to the absolute brink. Ultimately, its failure is as illuminating as any success. The cracks that doomed the project reveal the natural flaws and stresses hidden within the bedrock, flaws the master quarriers somehow missed in their initial inspection. It shows us that even with their profound understanding of stone, they were still subject to the unpredictable whims of geology. The abandoned project also tells a human story. It represents the loss of years of back-breaking labor, a devastating economic blow, and a very public setback for the priesthood and the pharaoh who commissioned it. Yet, they left it there. They didn't try to break it up for smaller blocks. This suggests it may have been left as a teaching tool for future generations of stoneworkers, a permanent lesson in both ambition and humility. It stands as a silent lecture on the limits of their technology, a boundary they discovered not through calculation, but through the thunderous crack of failing stone. Rising from the desert at Dashur, the bent pyramid presents one of ancient Egypt's most visually striking and enduring architectural puzzles. Unlike any other pyramid, its form shifts dramatically halfway to the apex, its lower half rising at a steep 54-degree angle, before abruptly kinking to a shallower 43 degrees for the remainder of its height. This gives it a distinctive, bent appearance, as if the pyramid itself is crouching under the immense weight of its own ambition. For a civilization that prized perfection and symmetry above all else, this apparent irregularity is deeply puzzling. Was this a mistake, a sudden panic in stone? Or was it a calculated, brilliant adaptation that saved the entire project from catastrophe? The answer reveals a critical moment of crisis and innovation in the evolution of pyramid building. The most widely accepted theory is that this was a dramatic, mid-construction correction born of terrifying necessity. The bent pyramid was built for Pharaoh Sneferu, the father of Khufu, and it was a bold experiment in scale and form. Its initial, steep angle was likely intended to create a truly monumental structure that reached for the sky. However, as the massive limestone blocks were piled ever higher, the builders began to see ominous signs of failure. The incredibly steep angle meant the weight of the stone was being distributed in a way that created immense outward pressure on the corners and base. Cracks may have begun to appear in the inner chambers or the outer casing. The entire structure was showing the terrifying signs of an imminent, catastrophic collapse. Faced with this reality, the chief architects made a fateful decision. They had to change the angle to save the pyramid. By shifting to a much shallower incline for the upper sections, they significantly reduced the volume and, more importantly, the weight of the remaining construction. This redistributed the structural load more evenly, easing the pressure on the already stressed foundation and walls and allowing the pyramid to stabilize. It was a masterclass in on-the-fly engineering problem solving. An alternative, though less dramatic, theory suggests the change was not a panic-driven fix, but a deliberate shift in architectural philosophy, influenced by a nearby disaster. Just a short distance from the bent pyramid stands the ruined shell of the Maidum Pyramid, also attributed to Sneferu. That structure suffered a catastrophic collapse, likely during its construction, and its rubble core is still visible today. It's possible that the architects of the bent pyramid, witnessing this failure firsthand, decided to alter their design preemptively. They may have calculated that continuing at the original steep angle was inviting a repeat disaster, and the bend represents a carefully planned, conservative adjustment to ensure stability. This theory paints the builders as more proactive and less reactive, learning from the failures of others rather than their own impending catastrophe. Regardless of the immediate trigger, the bent pyramid served as the crucial, live fire training ground for techniques that would define Egyptian architecture for centuries. The lessons learned here were not just theoretical, they were carved into the very stone of Dashur. The most important innovation was the introduction of the corbelled ceiling in the inner chambers. Instead of using flat, massive lintel stones that could crack under the tremendous weight of the pyramid above, the builders stacked layers of stone, with each successive layer projecting slightly inward over the one below. This created a towering, inverted stairway effect that effectively distributed the crushing weight down the walls instead of concentrating it on a single weak point. This corbelling technique would be perfected and used to spectacular effect in the Grand Gallery and the King's Chamber of the Great Pyramid just a generation later. The ultimate proof of the lessons learned from the bent pyramid's near failure stands right next to it, the magnificent Red Pyramid. Built immediately after for the same pharaoh, it rises from the desert at a consistent, safe 43-degree angle from base to tip, the exact same angle as the upper section of the bent pyramid. This is no coincidence. The Red Pyramid is the direct result of the hard-won knowledge gained from its bent sibling. It is the first true successful smooth-sided pyramid in Egypt, a flawless geometric marvel that stands as a testament to the iterative process of engineering. The bent pyramid, therefore, is not a failure but a pivotal prototype. It represents the moment Egyptian architects moved from ambition to applied physics, from simply piling stone high to understanding how to make it stand for eternity. Its strange, bent silhouette is a permanent monument to a civilization's capacity to learn, adapt, and ultimately, achieve perfection. This profound understanding of the cosmos, demonstrated in the very angles of their pyramids, finds its most dramatic and public expression not in the silent necropolises of the dead, but in the vibrant, living temples that served as the stage for their spiritual life. Across Egypt, from the sprawling complex of Karnak to the rock-cut marvel of Abu Simbel, we find structures engineered with a celestial precision so advanced it challenges our perception of their astronomical capabilities. These were not random orientations. They were deliberate, sacred alignments designed to harness the power of the sun and stars in spectacular, transformative events. The most famous of these is the celestial spectacle at Abu Simbel. The great temple of Ramesses II was carved directly into a mountainside with one audacious engineering goal in mind. For 364 days of the year, the inner sanctum, home to statues of the pharaoh and three gods, rests in deep shadow. But on two specific days traditionally believed to be October 22nd and February 22nd, dates flanking the king's birthday and coronation, a shaft of sunlight would pierce the 200-foot-long, precisely angled corridor. It would illuminate the statues of the sun gods Ra and Amun and the deified Ramesses himself, while leaving the statue of Ptah, the god of darkness, permanently in shadow. This was not a happy accident. It was the culmination of breathtakingly precise astronomical calculation and rock-cut engineering. The architects had to calculate the exact angle of the sun's rays on those specific days and then orient the entire temple and bore the entrance tunnel to that exact azimuth. A miscalculation of even a single degree would have meant the sunbeam would miss its mark entirely, a failure of both science and faith. This mastery of solar alignment is mirrored on a grander scale at the Karnak Temple complex in Thebes. The entire layout of Karnak, built and expanded by successive pharaohs over 2,000 years, is a testament to long-term celestial planning. Its main east-west axis is aligned so that on the winter solstice, the shortest day of the year, the setting sun would be seen to descend directly down the central axis of the temple, symbolically entering the sacred precinct. Even more remarkably, a special, solar altar courtyard was constructed by Akhenaten, designed so that the first light of dawn on the summer solstice would hit a specific point on the altar, marking the year's longest day. The incredible feat here is the maintenance of this precision across centuries of construction by different rulers with different architects. This implies the existence and preservation of a core body of astronomical knowledge, a sacred blueprint that guided all subsequent building, ensuring that each new pylon or court added to the complex continued to honor the original celestial orientation. The methods they used to achieve this accuracy without magnetic compasses or telescopic instruments are a subject of intense study. For solar alignments, the Indian circle method, using a central gnomon to track shadows, is a strong candidate, though executing it over the vast distances of a temple foundation would have been incredibly difficult. For stellar alignments, they likely relied on the meticulous observation of the rising and setting of key, decans, 36 stars, or constellations that rose consecutively over the horizon throughout the year, effectively acting as a star clock for the ancient Egyptians. By constructing simple sighting tools, perhaps notched sticks or aligned stones, they could have recorded the precise horizon points where specific decans appeared, using these fixed celestial markers to establish true north and other cardinal directions with remarkable fidelity. The purpose of these alignments was deeply multifaceted, blending the practical with the profoundly spiritual. On a practical level, the precise tracking of solstices and the heliacal rising of stars like Sirius, which heralded the annual life-giving Nile flood, was essential for agriculture and keeping an accurate calendar. But the spiritual significance was paramount. These light-based events were a form of divine communication. The sunlight illuminating the statue of a god was not just a symbol. It was the literal embodiment of the god's spirit rejuvenating the statue, transferring their power and presence into the earthly realm. It was a moment of cosmic harmony, where the architecture of the temple, the ruler on earth, and the gods in the heavens were all brought into perfect, engineered alignment. The temple was a machine for divine interaction, and its most critical components were not made of stone, but of light and time, engineered by astronomers who understood the rhythms of the universe with a clarity that still commands our awe today. But perhaps the greatest puzzle of the Great Pyramid lies not in the stones we can see, but in the tantalizing emptiness we cannot. For all its imposing mass, the pyramid is not a solid block. It is a complex structure riddled with passages, chambers, and, as we are continually discovering, voids. The existence of these hidden spaces presents a dual mystery: the how of their construction without collapsing the entire monument, and the profound why they were sealed away and forgotten for millennia. Modern technology is now pulling back the curtain on these secrets, and what it's revealing is forcing us to reconsider the very blueprint of this ancient wonder. The quest to see inside without dismantling the pyramid led to a revolutionary technique, muon tomography. Muons are subatomic particles that are created in the Earth's upper atmosphere and constantly rain down upon us, passing through solid matter. Denser materials absorb more muons, while voids allow more to pass through. By placing muon detectors inside the pyramid, scientists can essentially take an X-ray of the structure, mapping areas of differing density. In 2017, the Scan Pyramids project announced a staggering discovery: a massive void situated directly above the Grand Gallery. Dubbed the Big Void, this chamber is estimated to be over 30 meters long and has a cross-section similar to that of the Grand Gallery itself. Its precise shape and purpose remain completely unknown, as it is utterly inaccessible, hidden behind meters of solid stone. The engineering implications of such a void are staggering. Constructing a large, cathedral-like space within a millions of tons stone pyramid is an incredible risk. The weight of the masonry above creates immense downward and outward pressure. The builders brilliantly managed this through several ingenious techniques. The most famous is the series of relieving chambers above the king's chamber. These 5 compartments, capped with enormous granite slabs, are not rooms but structural safeguards. They distribute the colossal weight of the pyramid away from the ceiling of the king's chamber below, preventing it from collapsing. The ceiling slabs themselves are not flat but gabled, another brilliant feature that redirects the stress outwards toward the stronger core walls. The newly discovered Big Void may serve a similar, though as yet undetermined, structural purpose, acting as a pressure-relieving buffer for the Grand Gallery or other chambers beneath it. Speculation about the void's purpose ranges from the practical to the fantastical. The most conservative theory posits it is simply a construction gap, left to reduce the total weight of the pyramid and ease the burden on the inner chambers. Others suggest it could be a second Grand Gallery, perhaps part of an abandoned plan to build an even higher burial chamber. More imaginative theories propose it could be a sealed repository, holding the actual burial equipment of Khufu, or even a library of lost knowledge from a much older, advanced civilization. The frustrating and thrilling truth is that we simply do not know. Its inaccessibility is a testament to the builder's intent. This was not a space meant to be visited. It was buried, hidden, and integrated into the very fabric of the pyramid's design. This leads to the ultimate question: why go to such extraordinary lengths to build these massive, hidden internal spaces? The answer likely lies in a combination of structural necessity and profound religious belief. On a practical level, the voids were essential for stability, a calculated engineering solution to a monumental physics problem. But for the ancient Egyptians, the pyramid was more than a tomb. It was a machine for resurrection, a conduit to the stars. The specific placement and orientation of every chamber and passage held deep astrological and spiritual significance. A hidden chamber might have served a ritual purpose, representing a secret part of the pharaoh's journey through the underworld, a celestial counterpart to a star not visible to the naked eye. The voids are a permanent reminder that the Great Pyramid's true complexity is not just in its visible architecture, but in the invisible, sacred geometry that guided its creation, a blueprint we are only just beginning to perceive. Now, let's shift our focus from the soaring heights of the pyramids to their foundation on the Giza Plateau, where another class of engineering mystery rests in plain sight. The Valley Temple of Khafre, often overshadowed by the pyramid it serves, is a monument to a different kind of ambition, not height, but sheer, overwhelming mass. Here, the builders employed a cyclopean style of architecture, using colossal blocks of limestone that defy easy explanation. We're not talking about the multi-ton blocks of the pyramid core. We are looking at stones that are an order of magnitude larger, with some individual blocks estimated to weigh a staggering 200 tons. To put that into perspective, that's the equivalent of stacking 4 fully loaded modern semi-trucks into a single, perfectly carved piece of stone. The precision with which these behemoths are joined is what makes the sight so utterly baffling. The gaps between these monstrous blocks are virtually non-existent, with tolerances that mirror the mind-bending accuracy we see inside the Great Pyramid. The stones are not simply stacked, they are intricately interlocked, with complex angles and joints that suggest a level of planning and execution that seems almost supernatural. This creates an obvious and pressing question. Why? Why go to the extraordinary effort of using blocks of such insane proportions when smaller, more manageable stones would have achieved the same structural goal? The temple's walls would have been just as strong, and certainly far easier to build, with smaller masonry. Several theories attempt to answer this. One prevailing idea is that this was a deliberate display of power and permanence. By using stones so immense that they could never be moved or looted, Khafre was making a statement about the eternal, unassailable nature of his divine authority. It was architectural intimidation on a grand scale. Another, more practical theory suggests that using fewer, larger blocks actually created a more stable structure resistant to earthquakes, as there are fewer weak points between joints for seismic energy to exploit. However, the most controversial theory proposes that these cyclopean blocks are evidence of a far older construction, predating Khafre entirely. Proponents of this view point to the stark contrast between the massive, exquisitely fitted limestone foundation courses of the temple and the smaller, rougher blocks used in its upper sections, arguing that the pharaoh simply built upon the remains of a much older, technologically advanced megalithic culture. The methods of quarrying, moving, and placing these blocks plunge us back into familiar, yet amplified, mysteries. Quarrying a 200-ton block requires the same techniques we saw with the unfinished obelisk, but the risks are multiplied exponentially. Transporting it from the nearby Makatim quarries across the Giza Plateau would have required a sledge so enormous and a workforce so vast it challenges the limits of Bronze Age logistics. The most perplexing phase is the lifting. How do you hoist a 200-ton block and precisely lower it onto a foundation course, especially when the fit is so tight that you have mere millimeters of error? The common theory of earthen ramps becomes almost farcical at this scale. The ramp needed to lift a block this heavy would have been a larger engineering project than the temple itself. This has led to speculation about the use of advanced leverage systems, counterweights, or techniques that have left no archaeological trace, pushing the boundaries of what we believe was possible. This style of construction doesn't exist in a vacuum. It invites compelling comparisons to other enigmatic megalithic sites around the world. The perfectly fitted, multi-angled polygonal masonry at Sacsayhuaman in Peru, the colossal foundations of Baalbek in Lebanon, and the massive blocks at Ollantaytambo all share this same signature of immense weight and impossible precision. While separated by vast oceans and thousands of years, these sites present a similar archaeological puzzle. The use of stonework so advanced it seems to belong to a different technological timeline. The Valley Temple of Khafre sits squarely within this global mystery, forcing us to wonder if we are looking at a unique flash of genius in Egypt, or perhaps a faint echo of a much older, lost architectural tradition that once spanned the globe. Deep within the Temple of Seti, the first at Abydos, a set of strange hieroglyphs has launched 1,000 theories and captured the imagination of the Internet age. Carved high on a lintel, these peculiar symbols appear, to the modern eye, to clearly depict futuristic machinery. A helicopter with a distinct rotor and tail, a submarine, a hovercraft, and even what looks like a kind of jet plane. For proponents of ancient astronaut theories, this is the ultimate smoking gun, seemingly irrefutable evidence that advanced technology existed in the distant past, or that time travelers visited the ancient Egyptians. The images are so uncanny, so perfectly recognizable to our modern sensibilities, that the coincidence seems impossible to dismiss. It feels like a clear message from the past, a deliberate record of things that should not have existed for another 3,000 years. However, the truth behind these enigmatic carvings is a fascinating lesson in archaeology, linguistics, and the power of pareidolia, the human tendency to see familiar patterns in random shapes. The mainstream and widely accepted explanation is a phenomenon known as a palimpsest. In ancient Egypt, stone was a valuable commodity, and temple walls were often reused. When a new pharaoh came to power, especially one seeking to legitimize his rule by associating with a revered predecessor, he might order the name and titles of a previous ruler to be chiseled out and replaced with his own. This is precisely what happened at Abydos, Egyptologists have determined that the section of wall in question was originally carved during the reign of Seti I, celebrating his many titles and names. Years later, his son, the great Ramesses II, likely had workers plaster over his father's cartouches and recarved the text with his own royal identifiers. Centuries passed, the plaster filling the original, deeper carvings eventually crumbled away and fell out, eroded by time and the elements. What remained was a complex, overlapping puzzle of two separate sets of hieroglyphs, one carved on top of the other. The helicopter, for instance, is not a single intentional image. It is the accidental byproduct of the carved feathers from Ramesses' name, the MS hieroglyph which represents a shrew, and the carved arm and drill from Seti's name, all superimposed upon one another. The human brain, wired to recognize patterns, looks at this jumble of lines and immediately connects the dots, assembling them into the most familiar shape it can find from its own modern database of images. We see a helicopter not because the ancient Egyptians saw one, but because we do. The same process creates the submarine and airplane from other combinations of recarved bird symbols, animal figures, and royal insignia. Yet, the persistence of the alternative theory speaks to a deeper human desire. The idea that our ancestors might have possessed lost knowledge or been visited by advanced beings is a powerful and seductive narrative. It challenges the conventional, linear progression of history and technology, suggesting tantalizing cycles of rise and fall, or outside intervention. This narrative often arises from a subtle underestimation of ancient peoples, the notion that they could not possibly have built the pyramids or aligned the temples so perfectly without some external help. The Abydos helicopter becomes a convenient symbol for all those larger, unanswered questions, a simple visual answer to complex historical mysteries. It's a classic case of seeing what we want to see, of fitting ambiguous evidence into a pre-existing and more exciting worldview. Ultimately, the real story of the Abydos carvings is not about helicopters, but about the layered nature of history itself. The wall is a physical record of a political act, a son's attempt to claim his father's legacy. It is also a record of natural decay, as time slowly revealed the hidden text beneath. And now, in the modern era, it has become a record of our own cultural imagination, a Rorschach test that reveals our hopes, our fascinations, and our sometimes overwhelming desire to find connection and mystery in the ancient world. The true feat of engineering here is not in the carving, but in the incredible ability of the human mind to engineer meaning from the chaotic overlap of time and stone. Long before the smooth, geometric perfection of Giza, the Egyptian landscape was forever changed by a single, revolutionary structure that broke with all tradition. This was the step pyramid of Djoser at Saqqara, the world's first major stone building, and a breathtaking leap into the architectural unknown. Its construction was not an evolution, but a revolution, a series of brilliant engineering gambles that had never been attempted on such a scale. At the heart of this revolution was a genius named Imhotep, a man so revered for his accomplishments that he would later be deified. His challenge was monumental, to create an eternal tomb for the pharaoh that would reach for the heavens, but to do so using construction methods previously reserved for temporary materials like wood and mud brick. The pyramid's iconic stepped design was not the initial plan. It began as a simple, rectangular mastaba tomb, a flat roof structure common for elites. But Imhotep's ambition grew, and he envisioned stacking mastabas of decreasing size on top of one another, creating a stairway to the stars. This iterative design process itself was a stroke of engineering genius, as it allowed for constant testing and adjustment. However, stacking these massive stone layers created an immense and unfamiliar downward and outward thrust. To counteract these destabilizing forces, Imhotep's team pioneered a clever solution: the use of packing stones. The core of the pyramid was not built with perfectly fitted blocks from the start. Instead, they first erected a rough, internal framework of stone walls, creating a honeycomb of compartments. These compartments were then packed tightly with rubble, loose stone, sand, and clay. This filling acted as a malleable, self-adjusting mass that could absorb shifts and settle without cracking. effectively creating a stable, consolidated core that supported the more precisely laid outer layers. This entire endeavor marked a historic transition from perishable materials to eternal stone. For the first time, builders were working in limestone, translating techniques from woodworking and mud brick construction into a new, permanent medium. You can see this translation in the details. Some of the oldest stones in the complex are carved to resemble log roofs, reed walls, and even rolled-up reed mats. They were literally thinking in the old language while writing a new one in stone. This experimental phase is visible in the pyramid's very structure. The outer casing stones were attached not with mortar, but with huge dovetail-shaped cramps to hold them fast, another technique borrowed from woodworking. Every step was a calculated experiment, a hypothesis tested with thousands of tons of stone. Yet, for all its revolutionary success, the step design was ultimately abandoned within a few generations. The reason lies in its inherent structural limitations and the evolving religious beliefs of the Egyptians. The steps, while stable, created numerous weak points. The corners of each tier were vulnerable to erosion and damage over centuries. Furthermore, the structure was a series of right angles, which concentrated stress. The true, smooth-sided pyramids that followed, pioneered by Sneferu, addressed this by distributing the weight more evenly along a continuous, sloping plane. There was also a powerful symbolic shift. The stepped pyramid was a stairway for the pharaoh's soul to ascend. The true pyramid, with its gleaming, polished sides, was seen as a petrified ray of the sun, a ramp for the pharaoh to join the sun god Ra in his celestial journey. The smooth surface was not just an engineering improvement, it was a theological one. The step pyramid's enduring legacy, therefore, is not in the form that was copied, but in the boldness it inspired. It proved that stone could be used on a colossal scale. It established the principle of the architect as a master innovator, and most importantly, it demonstrated that a structure could be built to last not just centuries, but millennia. Its slightly ragged profile, standing against the sky at Saqqara, is a monument to the first, audacious attempt to build for eternity. A successful experiment that gave the Egyptian engineers the confidence to reach for the even more ambitious perfection of the Great Pyramid. While the pyramids reached for the sky, another monumental engineering project was transforming the Earth itself, turning a vast desert oasis into the breadbasket of ancient Egypt. In the Fayum Depression, a region cradled by the Nile's bounty yet threatened by its whims, pharaohs of the Middle Kingdom undertook a hydrological feat of staggering ambition, the taming of Lake Moeris. This was not merely about irrigation, it was a wholesale re-engineering of an entire ecosystem. A massive public works project that demanded a deep understanding of hydrology, geology, and civil engineering on a scale rarely attempted in the ancient world. The goal was to harness the annual Nile flood, using the natural basin of the Fayum as a massive regulating reservoir to control water flow, prevent catastrophic flooding downstream, and create vast new tracts of arable land. The central genius of the scheme was the creation of a massive canal, later known to the Greeks as the Bar Yosef, which diverted a branch of the Nile directly into the Fayum's basin. But this was no simple ditch. This was a carefully calculated conduit, its gradient and width designed to manage a specific volume of water. To control the flow, engineers constructed a series of dikes, sluice gates, and diversion barriers. These structures acted like a massive valve system, allowing them to channel the nutrient-rich floodwaters into the lake during the inundation, and then strategically release the stored water back into the Nile network during the dry season, ensuring a consistent water supply for farms across the region. The scale of excavation and earth moving was Herculean, involving the coordinated labor of thousands to reshape the very landscape. Yet, the most intriguing mystery of Lake Moeris lies not in the grand canals, but in the more intimate and now invisible technology that distributed the water to the fields. Ancient sources, including the Greek historian Strabo, make tantalizing references to water-lifting devices used in the region, which he and others called sekias. These were not the simple Shaduf counterweight buckets used elsewhere. They were mechanized wheels, likely made of wood and pottery, that could be turned by oxen or laborers to lift large volumes of water from the canals to the higher field embankments. If these devices were in use during the height of the Fayum's development, it would represent a quantum leap in irrigation technology, a precursor to the Noria wheels of the Islamic period. The frustrating absence of physical evidence wood and pottery rot away leaves this a shadowy hypothesis. Were these devices an innovation of the Ptolemies that Strabo projected onto the past, or were they a much older, pharaonic invention that has simply been lost to time? The impact of this engineered landscape was profound. The Fayum was transformed into a lush, highly productive agricultural hub, a testament to the state's ability to manage resources and command large-scale labor for public benefit. It supported a booming population and became a vital economic center for the Middle and New Kingdoms. The very success of the system, however, contributes to its mystery. Why is such an advanced hydrological network not more explicitly detailed in tomb paintings or hieroglyphic texts? The answer may lie in the nature of the technology. Grand temples and pyramids were monuments to gods and pharaohs, designed for eternal glory. Canals, dikes, and water wheels were practical, utilitarian achievements. Their glory was in the harvest, not in the afterlife. They were the unsung infrastructure that powered the civilization, engineered not for immortality, but for life itself, and their secrets have faded along with the wood and earth from which they were made. Standing proudly in the crimson light of the setting sun, the Red Pyramid at Dashur is more than just another tomb. It is a monument to hard-won success, a perfect geometric form born directly from the rubble of failure. If the bent pyramid next door is a lesson in panicked adaptation, and the Black Pyramid a cautionary tale of foundational neglect, then the Red Pyramid is the triumphant graduation. It represents the moment when Egyptian architects finally cracked the code, synthesizing everything they had learned into the first successful, truly smooth-sided pyramid in history. Its name comes from the reddish hue of the local limestone used in its core, but it could just as easily symbolize the blood, sweat, and fiery determination that went into its flawless construction. The most immediately visible innovation is its angle. Rising from the desert at a consistent 43 degrees from base to apex, this shallower incline was not an arbitrary choice. It was the direct result of empirical testing. The upper section of the bent pyramid had been completed at this same angle to prevent its collapse, and it had worked. The builders, likely under the same pharaoh, Sneferu, took that successful outcome and applied it as the founding principle for this new project. A lower angle meant less height for the same base size, but it also meant exponentially less stress on the structure. The weight of the masonry was distributed more evenly inward towards the core, drastically reducing the outward thrust that had threatened to tear the bent pyramid apart. This was a fundamental shift from aiming for the tallest possible peak to achieving the most stable possible form. But the genius of the Red Pyramid is not just skin deep. Its true strength lies hidden within its core. Moving decisively away from the fatal mud brick experiment of the later Black Pyramid, the builders returned to stone, but with a crucial refinement. Instead of using rough, irregular rubble, the core masonry consists of carefully quarried, local limestone blocks cut to a consistent size and laid in horizontal courses. This created a far more cohesive and unified internal structure. The blocks could bear weight evenly and transfer loads efficiently down to the foundation, unlike mud brick, which compresses and shifts, or haphazard rubble, which can settle unpredictably. The builders also paid meticulous attention to the foundation, ensuring it was level and built on stable ground, having learned the terrible cost of overlooking this first, critical step. Achieving its iconic smooth shape was the final masterstroke. The internal core was built in steps, much like the step pyramid of Djoser. Then the builders faced the immense task of filling in these steps to create the smooth, sloping plains. This was done using casing blocks, carefully cut Tura limestone blocks, with flat bottoms that would sit securely on the stepped core, and angled sides that would form the smooth outer skin. The precision required here is astounding. Each casing block had to be individually cut to fit its specific position in the matrix of the pyramid's face. They started from the bottom and worked their way up, constantly checking and adjusting the angles to maintain the perfect 43-degree slope, all the way to the capstone. The use of a simple but effective tool like a boning rod, A straight edge used with a plumb line to check for flatness would have been essential, but the consistency across the entire massive surface suggests an almost intuitive understanding of geometry and an unparalleled level of craft discipline. Today, the Red Pyramid stands as one of the best preserved pyramids precisely because of these thoughtful engineering choices. Its stable angle and strong core have allowed it to withstand 4.5 millennia of earthquakes, extreme heat, and rare desert downpours. While its fine white Tura limestone casing was largely stripped away over the centuries, much like the pyramids at Giza, its robust core remains largely intact, its silhouette still sharp and unmistakable against the sky. It is the silent, successful older sibling to the Great Pyramid, the proof of concept that gave Khufu's engineers the confidence to build even higher. It proves that the path to perfection in ancient Egypt was not a straight line, but a series of iterations, failures, and brilliant corrections, all culminating in this enduring, rust-colored marvel. Yet this entire conversation around stone and abrasives leads us to a more fundamental, and perhaps more mystifying, question. If the abrasive slurry did the actual cutting, what was the point of the copper tool itself? This is where the mystery of their metallurgy deepens. Copper is notoriously soft and malleable. A thin saw blade or a tubular drill made from pure copper would have bent, warped, and worn away to nothing long before it could guide an abrasive through a significant depth of granite. The tools had to possess a certain level of rigidity and durability to function as effective platforms for the abrasive. This has led to intense speculation that the Egyptians were not working with pure copper, but with a hardened copper alloy. The most likely candidate is arsenic copper. By adding a small percentage of arsenic to molten copper, ancient metalsmiths could create an alloy that was significantly harder, stronger, and more resistant to wear while still being malleable enough to be shaped into tools. Archaeological evidence shows that arsenic copper was known and used in pre-dynastic Egypt, before the rise of the pyramid builders. However, working with arsenic copper is incredibly dangerous, as heating it releases toxic fumes, leading to severe health problems for the smiths. Could the quest for harder tools have driven them to accept this risk? Perhaps they developed other, unknown alloys. Some researchers have even pointed to rare artifacts showing traces of tin, the key component of true bronze, appearing earlier than previously thought, though this remains a contested area of study. The sheer scale of the tool production is another staggering consideration. To outfit the teams working on a single sarcophagus or obelisk would have required hundreds, if not thousands, of these metal tools. They would have been consumable items, worn down and replaced constantly. This implies a massive, organized industry behind the scenes, mines producing vast quantities of raw copper, smelters and forgers working tirelessly to produce tools, and a logistics network to keep them supplied to the quarry and construction sites. The true engineering feat may not be the individual tool, but the immense industrial machine that produced and maintained them, an operation that has left almost no trace in the archaeological record. Ultimately, the precision of their work suggests a level of skill that transcends the tools themselves. The flawless flatness of a sarcophagus lid or the perfect right angles of its interior were likely achieved through a final, painstaking process of precision grinding and lapping. After the saws and drills had done the rough work, artisans would have used handheld rubbing stones of increasingly fine abrasives, constantly checking their progress with straight edges and square levels, to achieve that final, breathtaking accuracy. This was a marriage of material science and sublime craftsmanship. Their metallurgy provided the durable, workable tools to remove stone on a massive scale, but it was their unwavering dedication to perfection, their patience, and their profound understanding of geometry and measurement that transformed raw stone into these eternal, enigmatic masterpieces. The mystery is not just in what their tools were made of, but in the knowledge and skill held in the hands of the people who wielded them. Nestled at the paws of the Great Sphinx, shrouded in the grandeur of the Giza Plateau, lies a structure that is in many ways even more enigmatic than the legendary statue it accompanies. This is the Sphinx Temple, and its sibling, the Valley Temple of Khafre, a pair of monumental complexes built from impossibly massive blocks that challenge our understanding of their purpose. While traditionally classified as part of a funerary complex for the pharaoh Khafre, The sheer, overwhelming robustness of their construction and their peculiar features have led many to wonder if their true function was something far more profound and mysterious than simply a place for mortuary rituals. The first thing that strikes you about these temples is their raw, primal power. They are built in a cyclopean style, using colossal limestone core blocks that were quarried from the trench surrounding the Sphinx itself, some weighing over 200 tons. But it's the interior that truly confounds. The Valley Temple is lined with pristine, elegant casing stones of red Aswan granite, fitted together with the same hairline precision we see in the Great Pyramid. The floor is paved with massive slabs of translucent alabaster, a soft, fragile stone that seems like a bizarre choice for a high-traffic area. This combination of delicate, beautiful materials and brutally heavy, over-engineered foundations is a paradox. Why use easily scratched alabaster for a floor? Why sheathe the walls in exquisite granite if this was merely a utilitarian staging area for mummification? The quality of the craftsmanship suggests a purpose that demanded both immense durability and an atmosphere of refined, perhaps even luminous, beauty. This leads to the central mystery: what actually happened inside these temples? The standard explanation is that they were used for the purification and mummification of the pharaoh, a place where the body was prepared for its eternal journey. But the architecture tells a more complex story. The temples are essentially open courtyards, exposed to the sky, with a central altar and a series of narrow, enigmatic niches set into the walls. There are no hidden chambers, no secret crypts. The entire ritual space is right there, centered around what appears to be a focus on the heavens above. This open-air design, combined with the specific alignment of the entire complex, points strongly towards a function deeply tied to astronomy. The entire Giza Plateau is a masterwork of celestial alignment, and the Sphinx and its temples are key players in this cosmic plan. The Sphinx itself is famously oriented due east, directly facing the rising sun on the equinoxes. The temples are precisely aligned with the Sphinx and the second pyramid, creating a sacred geometric relationship. Some researchers propose that the open court of the Valley Temple functioned as a kind of ceremonial observation platform. During key astronomical events, like the heliacal rising of Sirius or the solstice sun, the interplay of light and shadow across the alabaster floor and granite walls could have created a breathtaking spectacle. A play of light designed to mirror the cosmic order and facilitate the pharaoh's transformation from a mortal ruler into a divine star. Another compelling theory suggests the temples were dedicated to the first and last light of the sun god, Ra. The eastern-facing Sphinx temple could have been for solar rituals at dawn, celebrating the sun's rebirth, while the Valley Temple, with its connection to the netherworld, might have been for ceremonies at dusk, marking the sun's journey into the underworld. The alabaster floor takes on new meaning in this context. When illuminated by the low-angled rays of the rising or setting sun, the translucent stone would have glowed with an internal light, perhaps symbolizing the primordial waters of creation or the luminous path the pharaoh's soul was to travel. The massive, unshakable granite blocks would represent the eternal and unchanging nature of this cosmic cycle. The true purpose of the Sphinx temple likely wove all these threads together. It was probably a multifunctional sacred space where the boundaries between the funerary, the astronomical, and the divine were blurred. It was a place where the dead pharaoh was not just prepared for burial, but was ritually transformed and launched toward the stars using the power of aligned architecture and celestial observation. Its enduring mystery lies in the fact that the rituals themselves, the specific chants, the precise movements of the priests, and the full sensory experience of the ceremonies have been lost to time. We are left with the silent, majestic shell, a machine for cosmic connection, whose operating manual has faded, leaving us to decipher its purpose through the language of its immense stones and perfect alignments. And yet, even the granite giants of the Serapeum have a rival in mystery, one that brings us back to those enigmatic boxes with a renewed sense of awe. Earlier, we marveled at their placement and their impossible seams, but to truly grasp the depth of this engineering puzzle, we must focus on the very process of their creation. How does one hollow out the interior of a 100-ton block of granite? How do you carve out a perfect, smooth, rectangular void within solid stone, achieving flawlessly sharp 90-degree corners deep inside a material that laughs at soft copper tools. The challenge of hollowing presents a problem far greater than simply cutting a block in half. The volume of stone that had to be removed from the inside of each sarcophagus is staggering. To create the hollow interior, workers would have had to pulverize and extract many tons of granite from within a sealed space, working through a relatively small opening. The prevailing theory, as with other stonework, involves the use of tubular drills. We can imagine teams of workers, perhaps using a bow drill mechanism, patiently rotating a copper tube while an assistant constantly fed a slurry of quartz sand and water into the cut. The quartz, harder than the granite, would do the actual grinding as it was dragged under the copper tube, slowly eating a circular groove into the stone. To hollow the box, they would have drilled a series of these holes closely together, like a honeycomb, and then broken out the webs of stone between them before grinding the resulting rough surface smooth. But this is where the theory meets its most severe test: the corners. The tubular drill leaves a naturally rounded, concave groove, yet the interior corners of the Sarcophagi boxes are famously sharp and precise. How did they achieve that? The only way to create a sharp internal corner with primitive tools is through an agonizing process of grinding with a hard, square-edged stone. An artisan would have had to take a piece of dolerite or another hard rock, shape it into a right angle, and then spend countless hours, perhaps even months, manually rubbing it back and forth in the corner to slowly wear the granite down to a perfect edge. The level of patience and skill this implies is almost beyond human comprehension, yet the evidence is right there in the stone. This has led to more speculative, yet fascinating, theories about their methods. Some engineers and machinists who have examined the boxes point to the sheer consistency of the surfaces and the precision of the angles, arguing that the work shows signs of a fixed, mechanical process rather than freehand carving. They note that the feed lines from the drilling process, visible on some unfinished pieces, show a remarkable consistency in depth and spacing, suggesting a tool that was powered in a very steady, predictable way. This has fueled the controversial idea that the Egyptians might have used a mechanical drill, perhaps one weighted with heavy stones to provide constant pressure, or even turned by a large team walking in a circle. A more extreme theory suggests the use of diamonds or other superhard crystals embedded in their drill bits, though no archaeological evidence for such a practice has ever been found in Egypt. The most perplexing part of this entire puzzle is the complete absence of the tools themselves. If this work was done on an industrial scale to produce 24 of these monstrosities, where are the drills? Where are the saws? Where are the piles of worn-out tools? Copper is a valuable commodity that was often recycled, but even broken tools and tool fragments are common finds at other archaeological sites. The sheer lack of any tools that match the capability implied by the finished product is a silence that echoes almost as loudly as the boxes themselves. It forces us to consider uncomfortable possibilities. Were these tools so valuable they were all meticulously collected and resmelted? Or does their absence point to a technique or technology that we have simply failed to recognize? This last question inevitably leads us to wonder if such impossible precision was even necessary for a burial box. The Apis bull was a sacred animal, but was it so sacred that it required a coffin machined to a tolerance of a fraction of a millimeter? This discrepancy between the mundane assumed purpose and the extraordinary effort involved has led to alternative speculations about the box's true function. Could they have been designed as resonant chambers for acoustic or vibrational rituals? Granite, with its dense crystalline structure, can transmit sound and vibration in unique ways. Was the perfect geometry and polish required to achieve a specific harmonic frequency? Or, as some have more esoterically suggested, were they intended to hold something else entirely, something that demanded an absolutely perfect seal, perhaps for a chemical or alchemical process that has been lost to history? The empty, silent boxes offer no answers, only the testimony of their own impossible perfection, a stone-cold mystery that continues to challenge the very narrative of technological progress. We've marveled at the cutting, the moving, and the lifting, But this brings us to one of the most fundamental and hotly debated mysteries of all. How did they actually get those massive blocks hundreds of feet into the air? The prevailing image in the popular imagination is a long, straight ramp swarming with laborers dragging a stone on a sledge. And for good reason, ramps are the most logical and physically plausible solution. But the moment you try to apply that simple idea to the monumental scale of the Great Pyramid, the theory begins to crack under the weight of its own logistical nightmares. The real mystery isn't whether they used ramps, but what kind of ramps they could have possibly used that wouldn't have been a more colossal undertaking than the pyramid itself. Consider the most straightforward concept: a single, massive straight ramp built directly against one face of the pyramid, growing longer and higher as the structure rose. The numbers quickly become astronomical. To reach the top of the 480-foot Great Pyramid at a manageable incline of, say, 10 degrees, this ramp would have needed to be nearly a mile long. The volume of material required: bricks, gravel, sand, and gypsum mortar would have been immense, potentially rivaling or even exceeding the volume of the pyramid it was meant to build. The quarrying, transport, and construction of this auxiliary structure would have effectively doubled the project's workload. Then, upon the pyramid's completion, you'd be left with a mountain of rubble to dismantle and dispose of, a task of staggering proportions for which there is curiously little archaeological evidence. No remnants of such a gigantic embankment have been found around the Giza Plateau, and it seems an inefficient use of a civilization's resources, no matter how well organized. This has led to the proposal of more efficient, albeit more complex, designs. One compelling idea is the zigzag ramp, which would have run diagonally back and forth across a single face of the pyramid. This design would be much shorter in length than a straight ramp, requiring less material overall. However, it introduces a new set of formidable challenges. Negotiating sharp, 90-degree turns with a multi-ton block on a sledge would have been an incredibly difficult maneuver, requiring immense space at each corner for teams of workers to pull and pivot the cumbersome load without it careening off the edge. The turning points would have been constant bottlenecks and dangerous weak spots in the entire operation. Perhaps the most elegant and widely discussed theory is the internal spiral ramp. This concept suggests that a ramp corkscrewed its way up around the outside of the growing pyramid, its surface later buried beneath the final smooth casing stones. This would solve the problem of immense external material and would allow blocks to be moved upward in a continuous, gradual ascent. The appeal is obvious, but the problems are equally significant. The corners of the pyramid would have been major obstacles, requiring incredibly tight turns that would be nearly impossible for long, heavy sledges. Furthermore, as the ramp spiraled upward, the working space on the upper levels would have become extremely narrow and congested, making it difficult to maneuver the largest blocks, especially the massive granite beams for the king's chamber that were installed deep within the structure. Most critically, if such a ramp were encased within the finished pyramid, we should be able to detect its ghostly imprint with modern technology like muon scanning. While the Scan Pyramids project did discover the large void above the Grand Gallery, no evidence of a definitive, ramping internal structure has been conclusively identified. The lack of any definitive archaeological evidence for a single, primary ramp style has led most Egyptologists to a hybrid theory. Perhaps the builders were pragmatic, using different types of ramps at different stages of construction. A massive straight ramp or a gentle rubble embankment could have been used for the initial, massive lift of the lower third of the pyramid. Then, as the structure narrowed and the focus turned to precision placement, a more complex zigzag or internal spiral could have taken over. This combination approach feels intuitively correct, leveraging the strengths of each method while minimizing their weaknesses. But it remains, like all ramp theories, a model built on logic and necessity rather than on hard proof. This enduring mystery forces us to consider a more radical possibility, that we are still missing a key piece of the puzzle. Could the ancient Egyptians have possessed a clever, simple technique that has left no archaeological trace? Some have speculated about the use of levers and counterweights in a repeating cycle to walk blocks up a series of steps. Others wonder if they used the pyramid's own growing structure as a lifting device. perhaps employing a system of ropes and pulleys from the top down. The frustrating and exhilarating truth is that the construction ramps represent the ultimate cold case. The methods were so effective that they left behind the perfect crime scene, a finished pyramid, with all the tools, ramps, and scaffolds cleared away, leaving us to reverse engineer one of history's greatest engineering achievements from its majestic, silent, and utterly unhelpful final product. But what if the stone itself was only half the story? What if the true purpose of these silent, massive structures was not just to be seen, but to be heard? This brings us to one of the most ethereal and puzzling mysteries of all: the strange and powerful acoustic properties engineered into the very heart of ancient Egyptian architecture. Step inside the king's chamber of the Great Pyramid, for instance, and you are stepping into a giant musical instrument made of stone. The room, built from immense blocks of resonant granite, has a unique sonic signature. Specific frequencies, particularly those in the lower bass range, don't just echo here. They amplify and sustain, creating a rich, immersive soundscape that seems to vibrate through your very bones. This isn't a subtle effect, it's a palpable, physical sensation that transforms the silent chamber into a space alive with energy. The question, of course, is whether this profound acoustic phenomenon is a happy accident of geometry and material, or one of the most sophisticated and overlooked engineering feats of the ancient world. The granite itself is a key component. This particular stone, rich in quartz crystals, is highly piezoelectric, meaning it can generate an electrical charge under mechanical stress, such as the pressure of sound waves. When sound resonates within the chamber, it doesn't just travel through the air. It vibrates the very walls and floor, potentially creating a subtle energetic field. The precise dimensions of the room and the specific angles of its construction appear to be perfectly tuned to enhance this effect. Modern experiments have shown that the chamber resonates most powerfully at a frequency close to 110 Hz, a sound that falls within the range of a low male voice. This is not a random number. Studies in neuroarchaeology have suggested that exposure to frequencies around 110 Hz can significantly alter brain function, quieting the language centers of the brain and potentially promoting states of heightened awareness, meditation, or even trance. This revelation opens a door to a completely different understanding of the pyramid's purpose. Perhaps these structures were not merely silent tombs, but dynamic spaces for transformation. Imagine a ritual ceremony within the king's chamber, priests chanting at this specific resonant frequency, their voices amplified and sustained by the stone, the very air vibrating with an energy that altered consciousness and facilitated a connection to the divine. The pyramid, in this view, becomes a machine not just for the pharaoh's celestial journey, but for the spiritual journey of the living who oversaw it. This field of study, known as archaeoacoustics, is now using sophisticated tools like audio mapping and frequency analysis to decode the sonic landscapes of ancient sites around the world, from the humming chambers of Maltese temples to the chanting galleries of Mayan pyramids. In Egypt, the evidence is compelling, suggesting a culture that understood the vibrational nature of reality in a way we are only beginning to comprehend. Yet the how remains as elusive as the why. Engineering a room to resonate at a specific frequency requires an understanding of sound waves and harmonics that we simply don't attribute to Bronze Age civilization. It implies they could calculate the behavior of sound within a complex geometric space before a single stone was cut. Did they use scale models filled with water, observing the ripple patterns to determine nodal points? Did they have a mathematical understanding of harmonics that has been completely lost to history? The precision required is breathtaking. A miscalculation of a few centimeters in the chamber's length or width, or a choice of a different stone, would have completely nullified the effect. The fact that they achieved it while also aligning the entire structure to true north and building it to withstand millennia suggests a holistic engineering philosophy where architecture, astronomy, geomancy, and what we might call vibrational science were all part of a single, unified discipline. The sound in the chamber is not an artifact. It is the signature of a lost science, a whisper from the past that we are still learning how to hear. Deep beneath the sands of Abydos, adjacent to the magnificent temple of Seti I, lies a structure that seems to defy both time and categorization. This is the Osirian, an enigmatic subterranean complex that feels like a relic from a far more ancient, forgotten age. Its design is a radical departure from the elegant, refined architecture of the New Kingdom. Instead of decorated walls and inscribed columns, we find a stark, powerful layout centered around a rectangular island surrounded by a water-filled moat, all constructed from massive, undecorated blocks of red granite that wouldn't look out of place at Giza 1,000 years earlier. The sheer weight and minimalist brutality of its construction pose a profound question. Is this a contemporary monument to the god Osiris, or are we looking at something far older? A pre-existing marvel that Seti I simply adopted and incorporated into his own sacred complex. The architectural dissonance is immediately striking. Seti's temple above is a masterpiece of New Kingdom artistry, covered in some of the most exquisite and deeply carved reliefs in all of Egypt. Its columns are slender and graceful. The Osirian, by contrast, is raw and primal. Its most defining feature is its cyclopean masonry enormous blocks, some weighing over 100 tons, fitted together with the same kind of precision we associate with the Old Kingdom. The style is reminiscent of the Valley Temple of Khafre at Giza, not the temples of Ramesses or Thutmose. The central island is bordered by 10 gigantic, monolithic granite pillars, each a single piece of stone. The whole structure was buried deep underground, originally accessed by a long, descending passageway, giving it the feeling of a primordial tomb or a chamber designed to symbolize the mythical underworld. This stark contrast is the root of the great dating debate. The conventional attribution points to inscriptions within Seti's temple that seem to reference the Osirian's construction, and cartouches of Seti and his grandson, Merneptah, were found on some of the granite. This suggests it was built in the 19th dynasty as a symbolic tomb for the god Osiris, designed to replicate the mythical first mound of creation that emerged from the waters of chaos. Yet, many archaeologists and engineers find this timeline deeply problematic. They argue that the construction technique is utterly anachronistic. The New Kingdom had long since moved away from such monumental, minimalist stonework. Why would Seti's architects, masters of sophisticated carving and design, suddenly revert to a building style that had been obsolete for over a millennium? The use of such colossal blocks underground, where their immense weight serves little practical structural purpose, seems like an echo of a different architectural philosophy entirely. This has led to a compelling alternative theory, that the Osirian is actually a much older structure, perhaps dating back to the early dynastic period or even before. Proponents of this view see it as a surviving fragment of a lost megalithic civilization, a sacred site that was already ancient and revered by the time of Seti I. In this scenario, Seti didn't build the Osirian, he discovered it. His contribution would have been to clear it of sand, make minor restorations, add his own cartouches to claim it, and then build his own temple directly above it to harness its immense spiritual power and antiquity. This would explain the stylistic disconnect perfectly. The cartouches are not proof of original construction, but of restoration and appropriation, a common practice among pharaohs who often claimed the works of their predecessors. The engineering of the Osirian only deepens the mystery of its purpose. Its subterranean nature and the constant presence of water in its channels are its most defining features. The structure was clearly designed to be flooded, with water flowing through its system of channels from a subterranean aquifer. This aligns perfectly with its accepted symbolic function, as a representation of the watery abyss of Nun, from which all life emerged, and the tomb of Osiris, god of the afterlife and resurrection. The chamber was a place of ritual reenactment, where the annual mysteries of the god's death and rebirth could be performed. However, the staggering effort involved quarrying and moving 100-ton granite blocks only to bury them forever underground suggests its significance was far greater than mere symbolism. Some researchers speculate it could have been part of a vast, ancient water management system, a geologically strategic structure tapping into the aquifer. Others, noting the peculiarly resonant properties of granite and the chamber's unique acoustics, wonder if it was designed as a massive sonic device. a frequency chamber for rituals intended to alter consciousness or communicate with the divine. The Osirian remains a profound enigma, a puzzle of stone and water that challenges our linear understanding of Egyptian history. It stands as a powerful reminder that the sands of Egypt still hold secrets that refuse to fit neatly into our textbooks. Whether it is a uniquely conservative New Kingdom project or the lone survivor of a lost epoch of building, its silent, sunken halls speak of a purpose so profound that it demanded an engineering effort of almost supernatural proportions, leaving us to wonder just how much of the ancient world's true story still lies buried, waiting to be understood. But our journey into the heart of these mysteries would be incomplete without addressing a question more foundational than any chamber or corridor. How did they even begin? Before a single multi-ton block was set in place, the ancient Egyptian surveyor faced a task of staggering geometric perfection. They had to lay out a perfectly square base for a structure covering 13 acres, with sides over 750 feet long, and do it with an error margin of less than 1/15 of a degree. We're not talking about a small garden plot. This is an area equivalent to over 7 American football fields, and the difference in length between its north and south sides is a mere 2 inches. This foundational act of precision engineering, achieved with what we would consider the most rudimentary of tools, is a feat that continues to humble modern engineers. So how did they transform the rugged, uneven bedrock of the Giza Plateau into a geometrically flawless starting point? While no ancient Egyptian surveying manual has survived, archaeologists and historians have reverse-engineered several highly plausible methods, all demonstrating a profound and practical understanding of basic geometry. The most famous of these techniques involves the creation of a perfect right angle using a simple loop of rope with 12 evenly spaced knots. This method is a physical demonstration of the 3-4-5 triangle principle, a cornerstone of the Pythagorean theorem that wouldn't be formally written down for another 2,000 years. By stretching the rope to form a triangle with sides of 3, 4, and 5 units, the angle between the 3 and 4 unit sides is a perfect 90 degrees. A team of surveyors could have used this knotted rope to establish the first perfect corner of the pyramid's base. From there, they could use long, taut measuring cords to lay out the first side, then swing the rope triangle to establish the adjacent side, and so on, moving around the perimeter to define all 4 corners. But establishing 4 right angles is only half the battle. The true challenge lies in ensuring the entire shape is not just rectangular, but a perfect square with all sides of equal length and perfectly parallel. This is where a second, even more elegant method might have come into play, one that relies on the geometry of the circle. After establishing the first baseline, surveyors could hammer a stake at each end. Then, using a long, unbreakable cord as a giant compass, they could swing an arc from each stake. The intersection point of these 2 arcs would lie exactly perpendicular to the center of the baseline. By carefully measuring an equal distance along this new perpendicular line from the baseline, they could pinpoint the exact center of the future pyramid's base. With the center point secured, they could then swing their giant cord compass again to inscribe a massive circle on the desert floor. The 4 corners of the square would then be defined by the points where the circle's circumference intersected with 2 lines drawn through the center point at right angles to each other. This method elegantly guarantees that all 4 corners are equidistant from the center, creating a geometrically perfect square. The true marvel, however, is not the theory, but the breathtakingly accurate execution. Imagine the practical hurdles. They were not working on a smooth, prepared surface, but on rough, sloping limestone bedrock. Their cords were likely made of perishable materials like flax or palm fiber, susceptible to stretching, shrinking with humidity, and sagging over long distances under their own weight. A slight breeze, a change in temperature, or a minuscule error in knot placement could have been magnified over hundreds of feet into a catastrophic misalignment. To combat this, they must have developed incredibly precise calibration techniques, perhaps stretching and wetting their cords beforehand to their maximum length to pre-stretch them, or performing their most critical measurements at the same time of day to ensure consistent temperature and humidity. The process would have been one of constant checking and rechecking, using the sun's shadow and the stars above to verify their work. A slow, painstaking dance of stakes, cords, and shouted commands across the vast construction site. This leads to the most profound question their work forces us to ask: what was the nature of their mathematical knowledge? The use of the 3-4-5 triangle and circle geometry shows they understood practical, applied mathematics. But did they possess deeper, theoretical knowledge that has been lost? The precise value of pi seems to be encoded in the proportions of the Great Pyramid, with the perimeter of its base corresponding to the circumference of a circle, with a radius equal to its height. Was this intentional, a conscious embedding of a mathematical constant into sacred architecture? Or is it merely an incredible coincidence born from a chosen slope angle? The frustrating and awe-inspiring truth is that we may never know the full extent of their intellectual world. Their surveying techniques were so effective, so ingrained in their craft, that they may never have felt the need to write them down in a theoretical textbook. The evidence of their genius is not in a scroll, but in the stone itself, a perfect square etched into the earth on a scale that defies belief. A silent testament to the minds that could measure the heavens and translate that knowledge onto the very ground beneath their feet. Yet even after untangling the construction ramps and decoding the sacred alignments, one of the most provocative and enduring mysteries remains. What was the true purpose of all this staggering effort? This brings us to a theory so radical, it reimagines the very essence of the Great Pyramid, transforming it from a silent tomb into a humming, ancient power plant. Proposed by authors like Christopher Dunn, the Giza power plant theory suggests the pyramid was not a monument to death, but a sophisticated machine designed to generate and transmit energy, leveraging the unique properties of its construction to harness the very vibrations of the Earth itself. The theory hinges on the pyramid's specific materials and internal design. Proponents point to the massive use of granite in the king's chamber and the relieving chambers above it. Granite is rich in quartz crystals, a mineral that is piezoelectric, meaning it generates a small electrical charge when subjected to mechanical stress or vibration. The hypothesis suggests the entire pyramid was engineered to resonate with the planet's natural vibrational frequencies, essentially turning the structure into a giant acoustic resonator. The subterranean chamber, with its mysterious pit and rough-hewn appearance, is theorized to be where water, perhaps from the hidden aquifer beneath the plateau, was broken down into hydrogen and oxygen through this resonant energy, a process known as electrolysis. The Grand Gallery, with its complex corbelled design, is reimagined not as a processional way, but as a sound chamber lined with resonators that amplified these vibrations, channeling the energy upward to be focused and emitted from the now missing gold or electrum capstone. On the surface, the idea is electrifying. It offers a unified, functional explanation for the pyramid's most puzzling features: the precision machining of the granite boxes, the strange, seemingly non-functional niches in the walls, the unique acoustic properties, and the choice of specific, piezoelectric stones. It connects the pyramid to the well-documented ancient Egyptian use of electricity, hinted at in the enigmatic Baghdad battery find and the controversial Dendera light reliefs, suggesting a lost technological epoch. However, the mainstream archaeological and scientific community presents a formidable wall of counter-arguments. The most significant objection is the complete and total absence of any evidence for the consumption or use of this theorized energy. Where are the wires, the conductors, the transformers, or any machinery that would utilize such power? If the pyramid was a power plant, what was it powering? There are no signs of ancient lighting, industrial facilities, or powered tools anywhere in the archaeological record of ancient Egypt. Furthermore, the theory requires a series of unproven assumptions: that the Egyptians understood and could manipulate subatomic physics, that the Nile was somehow diverted to create a water source for the proposed electrolysis, and that the pyramid's builders possessed a knowledge of electromagnetism that would not be rediscovered for millennia. So why does such a scientifically contested theory persist with such vigor? Its endurance speaks less to its archaeological validity and more to a deep, human desire to solve the ultimate puzzle. The Giza power plant theory, and others like it, fulfill a powerful narrative need. They offer a single, elegant, and technologically satisfying answer to a structure that otherwise seems overwhelmingly complex in its purpose. In a world run on electricity, it is natural for us to look at a masterpiece of engineering and assume it must have been a machine. These theories also stem from a subtle, modern bias that can underestimate ancient ingenuity, creating a perceived need for a lost advanced technology or even extraterrestrial intervention to explain achievements that simply don't fit our linear model of progress. Ultimately, the power plant theory may tell us more about ourselves than about the ancient Egyptians. It reveals our endless fascination with this singular wonder, our drive to project our own technological understanding onto the past, and our thirst for a grand unifying theory that makes sense of the impossible. While the scientific evidence for it remains in the realm of speculation, its cultural power is undeniable. It forces us to look at the Great Pyramid not as a static relic, but as a dynamic structure brimming with hidden potential, a capacitor of mysteries that continues to spark our imagination and challenge the boundaries of what we believe is possible. For centuries, the image of the pyramid builders was shaped by a grim and persistent myth, that of countless slaves, driven by the lash under the scorching sun, dying by the thousands to erect a pharaoh's tomb. This narrative of brutal oppression, popularized by Hollywood and romanticized by historians like Herodotus, painted the construction of the Great Pyramid as an act of absolute tyranny. But in the late 1980s, a groundbreaking archaeological discovery just south of the Giza Plateau began to shatter this ancient stereotype into a million pieces. The discovery of the Hayt el Girab site, aptly nicknamed the Lost City of the Pyramid Builders, revealed not a squalid slave camp, but a highly organized, state-planned community that functioned like a small, bustling city, complete with infrastructure that would be impressive even by modern standards. This wasn't just a place where workers slept. It was the very engine room of the Pyramid Project, and its existence forces us to completely rewrite the story of who built the pyramids and how they were treated. The engineering of this settlement reveals a logistical brilliance that mirrors the construction project it supported. Excavations led by Dr. Mark Lehner and Dr. Zahi Hawass uncovered long, gallery-style barracks capable of housing between 40 and 50 men each, suggesting a rotating workforce of skilled laborers rather than a permanent army of slaves. But the real marvels were the support facilities. They found massive, industrial-scale bakeries capable of producing thousands of loaves of bread every single day. The design was ingenious. Rows of conical clay pots were set into thick clay counters, creating individual baking chambers that would be heated from below. This allowed for high-volume, efficient production to feed a vast workforce. Next to these bakeries were equally large breweries, as beer was a dietary staple, a caloric necessity, and even a form of payment for the ancient Egyptians. The discovery of enormous vats for mashing grains and fermenting the brew shows a level of production planning that rivals any modern factory, all dedicated to sustaining the human machines building the pyramid. Perhaps the most telling find, however, was the evidence of advanced medical care. The excavation of skeletons from the nearby workers' cemetery provided stunning insights. Analysis of the bones showed signs of sophisticated trauma treatment compound fractures that had been cleanly set and had healed perfectly. Amputations that had been performed with such skill that the patients had lived for many years afterward. This is not the medicine of neglect. This is the evidence of a society that valued its skilled workforce immensely. A worker with a broken leg was not left to die or discarded. He was treated by what appear to have been highly competent physicians, given time to heal, and likely put on light duty. This level of care represents a huge investment in human capital, completely overturning the idea of a disposable labor force. It suggests that these workers were a prized national resource, skilled artisans and employees of the state who were well-fed, well cared for, and took great pride in their work. Yet, for all these answers, the Lost City raises even more profound questions about the pyramid's construction. If the workers were not slaves, how were they organized? The layout of the city itself provides clues. It is divided into clearly defined sectors, with separate areas for crews from different parts of Egypt, each likely named after their pharaoh, like the crew graffiti found inside the pyramid reading, "The Friends of Khufu." This points to a system of national service, a corvée labor system where communities across Egypt contributed men as a form of tax duty. These crews may have worked in rotating shifts, perhaps 3 months on, 3 months off, which would explain how such a massive project could be sustained over decades without burning out the population. The organization must have been military in its precision, with a clear hierarchy of foremen, scribes to manage ration distributions, and overseers to coordinate the work. The biggest lingering mystery, however, is what the city hasn't told us. We have found the bakeries that fed the workers, the clinics that healed them, and the barracks that housed them. But we have not found the central planning office. Where are the architects' quarters? Where is the repository for the blueprints and the schematics? There is no ancient equivalent of a site foreman's trailer, filled with papyrus scrolls detailing the lifting techniques or the ramp designs. This absence is deafening. It suggests that the most crucial secrets of the pyramid's construction, the master plans, the advanced mathematical calculations, the precise engineering diagrams were considered so valuable, so sacred, or so sensitive that they were kept elsewhere, perhaps within the inner sanctums of the temple complexes or even within the pyramid itself, hidden in chambers we have yet to discover. The Lost City gives us an unparalleled window into the lives of the workforce, but the minds of the master engineers remain as elusive as ever, their genius preserved only in the silent, towering stone miracle they left behind. Yet for all the grandeur of the pyramids and the temples, some of the most mystifying artifacts, left by the ancient Egyptians, are also some of the smallest. Tucked away in the earliest dynastic tombs, particularly beneath the step pyramid of Djoser at Saqqara, archaeologists have uncovered a staggering collection of over 40,000 stone vessels. Fashioned from incredibly hard materials like diorite, basalt, granite, and quartzite, these containers are not simple, crude pots. They represent a pinnacle of precision craftsmanship that, in many ways, rivals and even surpasses the workmanship found on a far larger scale in later periods. Their existence creates a bizarre technological paradox, a peak of artistic and engineering skill appearing at the very dawn of Egyptian civilization, a high point from which there seems to be a decline, rather than a steady progression. The sheer perfection of these vessels is what stops engineers and archaeologists in their tracks. Many were carved with walls so astonishingly thin they are almost translucent, a terrifyingly delicate feat when working with stone that ranks among the hardest substances on Earth. Their symmetry is flawless. When placed on a modern turntable and spun, they display a balance so perfect they show no wobble whatsoever, indicating a level of precision that implies the use of a rotational cutting device. The interiors are often just as meticulously finished as the exteriors, with smooth, consistent curves and, in some astounding examples, narrow-necked vases with hollowed-out interiors that a modern toolmaker would struggle to replicate without sophisticated, narrow-gauge drills. The surface finish is frequently a mirror-like polish, achieved on materials like gneiss and basalt that are notoriously difficult to buff to such a high luster. How was this achieved in the pre-dynastic and early dynastic eras, a time officially categorized as the very beginning of the Bronze Age? The tools attributed to this period, flint scrapers, stone hammers, and early copper chisels, seem utterly inadequate for the task. The evidence left on the vessels themselves, however, provides tantalizing clues. Many exhibit unmistakable marks of a rotary tool. There are clear, concentric grooves on the inside of bowls and the outside of vases that are the undeniable signature of a fixed-point cutting while the workpiece was turned. This has led to the compelling theory that the ancient Egyptians had developed a form of lathe. This wouldn't have been a lathe as we know it with a metal motor and geared parts, but perhaps a simple yet brilliantly effective apparatus. One plausible design involves a two-part spindle. The vessel blank would be fixed between two pivot points, and a cord would be wrapped around it. An assistant would pull the cord back and forth like a bow, spinning the stone back and forth rapidly while the craftsperson held a fixed, sharp cutting tool against it. To cut the hard stone, they would have employed the same abrasive slurry technology we see later using crushed quartz sand or emery with water, which would grind away the material as the piece rotated. Yet, this explanation, while logical, still struggles to account for the most complex pieces. How did they hollow out long, narrow necks while maintaining a consistent wall thickness? How did they achieve such a flawless polish deep inside a closed vessel? The level of skill and patience required is almost superhuman. This has fueled alternative theories, including the controversial idea that they possessed a lost method for softening stone using a natural chemical compound derived from plants or minerals, allowing them to work the material almost like clay before it rehardened. While no direct evidence for this exists, the perfection of the objects continues to invite such speculative questions. The most puzzling aspect of all is not how they were made, but why this technology appears to fade from the archaeological record. As we move into the height of the Old Kingdom and the age of the pyramids, we see a shift away from these exquisitely made individual stone vessels toward more mass-produced items made from softer materials like alabaster, or even faience and pottery. The incredible, time-intensive artistry of the early dynastic period gives way to a more pragmatic approach. The most likely explanation is a simple matter of economics and shifting priorities. Creating a single diorite vase with a bow-driven lathe and abrasives might have taken a master craftsperson months of painstaking work. As the Egyptian state centralized and embarked on massive projects like the pyramids, the focus of skilled labor and royal patronage shifted. The demand was no longer for tens of thousands of perfect, individual tomb goods, but for millions of limestone blocks. The art of precision stone vessel carving may not have been lost so much as it was sidelined, becoming a specialized, rare craft for the most elite purposes, while more efficient methods were adopted for the majority. These vessels stand as a silent, elegant mystery from the very foundation of Egypt. They suggest that the first pharaohs presided over a culture that had already mastered a form of precision engineering that would not become common elsewhere for millennia. They are a testament to a different kind of ambition, one focused not on overwhelming scale, but on impossible, intimate perfection, leaving behind a legacy in stone that remains a profound puzzle for the modern world. From the celestial alignment of the Great Pyramid to the submerged chambers of the Osirian, these 30 mysteries are far more than ancient trivia. They are profound puzzles etched in stone, each one challenging the very foundations of our historical and technological timeline. We've journeyed past obelisks that defy transport, peered into sarcophagi with seams tighter than a human hair, and stood in chambers that resonate with forgotten frequencies. We've seen evidence of machining that rivals modern precision and logistical operations that would be ambitious even today. Each feat, from the water management of the Fayum to the lathe-turned vessels of Saqqara, stands as a silent question mark, forcing us to continually re-evaluate what we think we know about human innovation. The true legacy of the ancient Egyptian engineers is not just in the monumental scale of their work, but in the breathtaking ingenuity they applied to seemingly impossible problems. They moved mountains of stone without the wheel, calculated the heavens without telescopes, and built for eternity with an understanding of materials and physics that continues to elude our full comprehension. Their achievements whisper of a depth of knowledge, a blend of practical skill and profound scientific insight that we have only begun to piece together. For every theory we propose, be it abrasive slurry, celestial observation, or ingenious ramp systems, there remain gaps, inconsistencies, and questions that our current models cannot comfortably answer. This is the thrilling frontier of Egyptology. It is not a closed book of solved equations, but a living field where every new technology, from muon tomography to ground-penetrating radar, promises to reveal another layer of the mystery. The sands of Egypt have already yielded the lost city of the pyramid builders, transforming our understanding of their society, and who knows what other revelations still lie buried, waiting for the right shovel or the right scan to bring them to light. The story is still being written. So what do you think? Which of these engineering feats leaves you the most baffled? Do you believe the ancient Egyptians possessed a lost technology? Or was their success purely a product of immense patience, brilliant organization, and a mastery of simple physics applied on a grand scale? Share your own theories and favorite mysteries in the comments below. I love reading your perspectives on these incredible puzzles. If you enjoyed this deep dive into the unknown, make sure to subscribe and hit the bell so you don't miss our next exploration into history's greatest enigmas. As always, thank you for watching, and keep wondering about the incredible secrets that still slumber beneath the desert.